And we're going to start with a blank scene. And also keep in mind that here, just a sense of units. If I create a 111 cube, that's going to be 1 meter. So would like to make a traffic scene. So keep in mind that this is 1 meter. So you may want to have a sense of scale when we're going to design our system. So we're going to start with making a car simulation. So for a car simulation to work, we first need to create our traffic network. And the traffic network will be just, the roads on which the cars will be able to drive on. And it will be relying on Maya curves. So let me create, I may want to have some visual help on my side. So I'm going to create like a 200 meter long plane. And I also going to have it with 208 as well. So that's 200 meters by 200 meters. So that's probably going to be the size of my network today. So obviously you can design the whole city if you'd like to, but here on my side, I just stick with a symbol setup. How do we create that road network? We're going to use the Maya curves. So, well, we can just use Bezier curve tool, for example. And I'm going to switch my view to go into top view. I'm also going to remove my my grid view. And what we want to do is every time we have a road section, we want to make a curve out of it. So let me just show you what I mean. So let's say I'm going to make like well, wait a minute. Better is to put it as a polygon. Okay, and I want to have actually 2 subdivision. So let's say the edges of my plane here is going to be my traffic system. So I want to draw in my setup here as many edges, as many curves as I have edges into my scene. So don't put everything into one curve. It has to be broken into 1, 2, 3, 4, etc., etc. So we want to make curve for every single of those edges, which will define our network. So make sure that here, especially that the one in the middle is not one curve, it's going to be really broken into 2 curves, because every time we're going to end and start a curve, we're going to consider there's a connection, like an intersection in between. So this is how we detect intersection. So to be honest, maybe the corners here, it's not an intersection. It's not connected to anything else. It could be one curve, but just as a rule of thumb, if we want to extend the system later because we want to add more, more roads from those points here, just break everything into separate curves. So we're going to draw, I don't know, 12 something-ish curve into the system. So let's do this. I'm going to go into the curve menu in Maya, select the basic curve tool, and I'm going to create a curve which go from here to there, roughly. They don't have to touch, each other. Press entry. So that's my first curve. I can just press, create another one there. So you can see I draw them like really roughly. They're not connected, but I don't really care. I can create one, let's say here, press entry there. So take some time to draw your network. You can make round curves if you want to make turns or that kind of stuff. Or here I'm doing kind of American city district stuff, but yeah, you can do whatever you want to. You can even put elevations in your curves if you like. So well, don't be crazy, don't put hundreds of curves, but let's create a system quickly. Let's do one here, one there, which will be my intersection here. I may want to create one here. Okay, already done. Great, and oops, I'm just going to expand that plane here and go back to my perspective view. So that's going to be my network here. So, well, I think it's not really mandatory here, but I can just clean those to make them So sorry, I'm not really, good and really proficient with Maya tools here. Okay. What is the tool to do those curves? That's just a regular Maya Bezier curve tool. So if you go into the create menu, create curve tools, you got plenty of different curves which propose different type of controls. Bezier is just one type of curve, so that's the one I've been using here. I just clicked on my first point and my last point, and just by doing so and press entry, that creates a new curve. So if you're going to create curve tool Bezier, you can see your cursor changed, and now you can click at the start and at the end, press entry. That creates a curve. And if you press G, G is just a shortcut in Maya to call back the previous tool you've been using. And press G. So you're able to create more curve. Press G, able to create more curve anyway. So yeah, that's just the regular Maya tool here, but use whatever you'd like here, no problem. So when I'm done here, I'm probably gonna group those curves. So I select them all, press Ctrl G, and let's change my plane white here. But we don't really care about the geometry. It's just that I want to really outline the curves and see them and have a sense of scale. But the plane is not going to be required. We just need to have those basic curves that I just created. So I'll let you 1 minute or two to finish with this. Like create your network. Make sure that it's actually big enough. So make sure from the beginning that you're creating the right size of curves. If you have to scale curves, make sure also to freeze transformation on it. So at the end, there are 111 scaled. And when you're good with this, so let's rename this traffic curves. Let's save my scene also in the meantime. So that's going to be day 4A. That's my traffic scene. Okay, and I'm going to assume that within the next seconds, you guys have done. And when you're done, you can just so select your curves, and we're going to turn those curves into a traffic system. So to do so, make sure that the curves are actually really selected. Do not select the group in which they are, like select the actual objects. And you can go into the Golaem menu. Because traffic is not something which is like super casual. So we do not have any shelf button regarding this. So it's going to be hidden into the menus there. So go into the Golaem menu, environment locator, and you can see you've got different locators you can create. You got the terrain. That's something we've been seeing. We've got the flock locator if you want to do birds. And if you do cars, you got the traffic locator. So if you click on the traffic locator while having all your curves being selected, you should see that now next to all of your curves, you've got some arrows appearing. So one series of arrows per curve in one direction, one series of arrow in the other direction. So that's our initial traffic system here, our initial lanes for each of the curves. So I'll let you finish this. So yeah, don't go too crazy with the setup. And once again, what I've been doing so far here is I just selected my curves, my Maya curves, and went into Golaem, environment locator, and I created a traffic locator. Okay, awesome. So now my lane are being displayed. And obviously what I want to do now is to specify per curve how many lanes I have. Here we've got one lane in one direction, one lane in another direction by default, but that's something which can be changed. So let's take a look what we have in our scenes. We have now a new GLM environment transform, which we can expand, and we can see we have within it our traffic locator. So the traffic locator is kind of the terrain, but for cars. So if we select it, we can see it's connected to the various curves which compose the traffic system. So you can still, add after more curves to your system if you need to have more. You can decide on which side of the road you'd like to drive. So you may see that right now we are moving forward on the right lane. So driving side is right, but if I say it's left, it's reverting the system. So if you want to make a UK or a Japanese traffic simulation, you can just switch this. You can specify if you want to switch lane and how long does it take to switch lane. And something which is interesting me here is the default road attributes panel. So by default, it's closed, so I can expand it. And I can change multiple parameters which will be replicated on all the system here. So I can change the width of my lane, so how large they are. So I think the default value is 3.5, right? What's the inner separation? So what's the distance between those? So here we set them up for all the curves, but we'll see afterwards that we can also tweak this on a per curve basis. So we can override those attributes on a per curve basis. So you want to make sure that you set up the most common values there. And afterwards on a per curve base, we're gonna change this. We can change the speed limits. Also, if we want our characters to go faster on a portion of the network, or if the speed is going to be the same. We can specify how many forward lane we have. So let's say you want to do, some motorway with 4 lanes on one side, like American style motorway. That's something you can do. I just stick with one, and or you can even do one-way network here. So put 0, and you just have a one-way network now. Is the speed in kilometers per hour or miles per hour? Seb, do you know what's the speed unit in the traffic system? Meters per second? Oh, okay, meters per second. Probably we need to put an actual unit that people can understand here. Okay, meters per second. So how's 45 meters per second in kilometers? Well, you know what? You just put some value. If it's not fast enough, you just increase it. So yeah, that's the rule of thumb here. So yeah, let's put back the system to 1 for 1 lane. Change my inner separation there. And yeah, we're good in terms of default values. And as I was saying, we can even override this, on a per curve basis, especially like here, the middle of my system, I would like those 4 curves to be a 2x2 road track. So if I select my actual curve in my system here, so if I select my Bezier curve, and if I check the extra attributes, so here that's a Maya node. So when it gets connected to a Golaem traffic node, we're going to add within that Maya node some new attributes. And as those new attributes, they're not recognized by Maya, they are stored into the extra attributes. So first select your curve, go into your extra attributes, and at the really bottom, you'll notice that you've got the same exact parameter that we had before. So we've got the lane width, inner separation, forward lane count, backward lane count, and back count, speed limits. And those are in yellow, which means that right now they are connected with the traffic system. So if I change the default attribute, it would replicate on all the curves which are still connected to it. If I want to override it on a per curve basis, so like here, I would like to have a 2x2 system. I'm just going to break connection here and just increase the number of lanes, forward and back lane, and the backward. And now on that specific curve, I'm having a different system. Then let's do this for the other curves. I'm gonna break connection here, increase it. 2 by 2. Do this. So you can, do whatever you want to. If you just want to change the speed, if you want to change the inner separation or whatsoever, let us know. Yeah, I'm seeing. I can see your question, Olivier. I think the error is something we fixed in 8.1.3. So should I assume that you're using a old version of Golaem, so probably 8.12? If you are, you can just ignore the error. I think it's actually displaying the traffic system anyway. That error is just obsolete stuff, which is not true anymore. So if it's displaying correctly the system, just ignore it. That's something we fixed into the newest version. So let's do it for that lane too. Break connection. So, well, you get the idea, right? You just shape your system the way you want to, change the speed on a per curve base. So you just define how does the character will behave on that system here. Great. As soon as you fixed all the parameters you wanted on your curves, we need one extra step to finish the system, because you may have noticed that every time we've got intersection here, we haven't defined any rule. So we'll have to define what's the rule when characters will reach that lane at the same moment. So is it going to be like a traffic light? Is it going to be like a right side priority? Is it just going to be like a junction? So nothing specifically will apply. So it will be your duty to actually define this for every single intersection that you have. So I'll let you finish with setting up the parameters. And when we're good, we'll go back into the traffic system. So that node is within GLM environments. So that's my traffic here. And we can see we've got something called crossing attributes. And we've got a button within that crossing attribute section called auto compute crossings. So that guy here will try to check where there are multiple curves connected or at least close to each other. And every time they figure that there's some curves close to each other, it's going to create automatically a crossing. So let's press on that button here. And now you can see that all my intersections in my system, they are now displayed with a circle. Those circled are new nodes which have been added to your scene. They are right under your traffic system that you can expand. So you can see all your different crossings there. And they all have their own attributes. So first thing we can do is probably change the size of the intersection. So it will be the range for which your entities are going to turn into. Also, while you are setting the radius, you also may want to say if this intersection is a junction. So a junction means that it will just be driving by right side or left side priority. So people will just pass if nobody's here. And if somebody is here, they will just let the priority. And if you don't click on junction, it will be a traffic light system with which you'll be able to control how long it will be green, orange, and red. So here I'm going to say that's a junction. And you can see as soon as you say, at least in 8.1.3, when you say it's a junction, the color of the crossing will change to green. And green means that there's no traffic light system appearing here. Here, I just have two curves being connected together. So that's clearly a junction. We don't want characters to stop when they come into that part here. That's going to be a traffic light. That's going to be a junction here as well. Let's make a junction there. Here as well. Here as well. And here, that's going to be my big crossing. So let's make it slightly bigger. Okay, not so bad. Probably that's going to be also a junction there. Great. So as you can see here, everything is a junction. So they'll just let priority, no specific role will apply when multiple characters will come to do sections there. But in the inner part of my network, there's going to be 2 traffic lights. So the orange one will be driven by traffic lights. There. Can you re-show how you made the intersection? Yeah, for sure. So I just went into the main traffic locator node. I went into the crossing attributes section. And on your side, as you haven't pressed on the autocomplete crossing, you've got that empty space. You can just press on that button here. And it will detect every time there are multiple curves which are next to each other. It will create automatically an intersection and add it into your scene and display it into your scene. After that, you can find back your crossings right under your traffic system. So if you expand your traffic system, you end up with all the crossings. And for each of those crossings, you can define what's the size of it. Is it going to be driven by a traffic light or just going to be driven by regular right side priority here? Awesome. So yeah, now my network is kind of done. And I can spawn my car entities within it. So the rest, the next step is going to be pretty similar to what we've been doing so far, which is we need to bring a car character into the scene. So I'm just going to bring a new entity type. And from the Golaem character pack, if we take a look in what we have, so in the character pack 813, the Golaem directory into characters, we have a casual car character. So casual car is a kind of an American car, which has 2 variations. One is just a regular car and one is a taxi version, like a New York style taxi. I'm just going to load that characters in. It's also going to ask me the shaders. So I'm going to grab the shaders for Arnold. So casual car underscore AR for Arnold. It will bring that character in the middle of my scene. And maybe we can also take a minute to check how does the character looks like. So as I said, it has a taxi variation. So this is why we've got the taxi sign on top of it. And just let's have a word about the skeleton here, because it's it's an unusual character, but we still want to animate it. So it has a root bone, which is here attached on the floor, but doesn't make any big difference. We've got some controls, some bone, which allows us to go on the front wheel center and on the back wheel center. And for every single wheel that we have, we've got 2 bones, one which is called front left, front right, and so on. This one will be used to make the actual steering of the wheels. And we've got another one right after, which will be used to make the rolling of the wheel. And each of the tires have those 2 bones, so we'll be able to control those and drive them using procedural animation afterwards. So let's take a look how probably it's mapped. So let's open, no need to do it on your side. I just want to show you how we mapped it. So we create a root, 2 limbs, one which goes from the root to the front bone, one which goes to the root to the rear bone, and just some fingers. So those are just mapped, so we can make some physics representation of them. And also there's a visual representation of them. And let's take a look at the geometry. So nothing too fancy here. It has wheels, it has accessories. Accessories are going to be the front light, the mirrors, etc., etc., which each of them is connected to its own shader. And more interesting is we're having the bodies, and the bodies allows us to make variation between a regular car. So regular car is just playing the regular body, and a taxi. and the taxi is actually playing the taxi body, which is different because it has a differentiator, and also the taxi sign. So we can make variation onto the character shape, character representation. Great. So let's now spawn some characters around. So I'm going to put that character here elsewhere in my scene so it doesn't bother me in terms of visualization. And I'll remove that cube here as well. Oops. Let me save the scene. Great. So when it comes to populating a traffic system, we probably want to use those curves also as a base source, right? So I can open my population tool. If you double click on the shelf icon, it will display the tool settings. And here, if you pay attention, we've been playing a lot with those population settings here, which allowed us to, draw different shapes. But what I will be more interested in today, especially within the cars, is to use the populate in selection panels. And especially one which is important, which is interesting here, is create particles around the selected curves. So all convenient, we've been doing curves for the traffic system. So let's use those same curves. So let's go into our traffic curves group, select each of those curves individually, or the one you would like to populate your characters on at least. And let's press on that population tool setting. As soon as you do this, you'll see that it will fill your whole environment with a full bunch of characters, and up to you to decide how many characters you'd like to have. So here it's apparently I can fill my system with almost 700 characters, but let's reduce that numbers. Let's put maybe, I don't know, 100 will be fine. We can probably also increase the distance between the characters, because here, my radius there, well, my tool representation here, they are circle based, but obviously a car cannot really represent it as a circle. So yeah, you may want to increase the distance so the car are not in collision right away when they are generated. So let's increase the distance. Great. And when you're happy with this, you can just press create and run your sim for a frame, and you'll see your characters appearing and displayed into your system. Yeah, true. If you pump up the slider for population tool, you will look like a Paris simulation where you're just stuck in traffic. Great. So if we check, we only have regular cars here. We don't have taxes. So let's maybe add some taxes. So yeah, by the way, let's do things properly. Let's rename that entity type node that we created car type. Okay, do I have to rename something else? I guess I'm good. Maybe I can rename my population tool just to say that's the car population. Oops, great. Okay, and let's put some taxis in. So you may have noticed that when I opened the character file, here my default rendering type, which gets assigned to my characters, is called regular car, and regular car just creates regular car characters, so no taxi at all. So we've got two ways: either you change the slider here, save the character file, and rethrow the scene, or here, as we've been creating two variation. One is the regular car, one is the taxi, and the taxi takes advantage of the taxi representation. What we can also do is go into the entity type, scroll until you reach the rendering attributes, and you can see by default it's going to be regular cars, but you can assign a new rendering type to your crowd, so taxi type, and you can just specify how many taxis you'd like to have in your scene. So here I'm saying 10% of my crowd is going to be taxis. And the next time you throw your sim, you end up with those yellow cabs, American style cabs there. Great, awesome. So so far those characters are obviously not moving, so that will be our duty here to add behaviors to those guys. So let's open the behavior editor. Let's save the scene. And let's open their behavior graph, which is right now empty. So maybe not a so tricky questions, but what behavior should we assign to those characters if we want them to move? So should we assign them with what we've been doing so far? We've been doing a lot of go-to navigation. So should we use those, or if not, which one should we take into account? So the last one, traffic go to, hopefully the icons are, variables enough. So let's put our mouse over the icon. So we've got one which is called traffic go to, which compute a path to a target using a traffic locator. Great. And next to it, we've got a traffic behavior. Traffic behavior define a traffic avoidance strategy. So obviously we don't want to use those one because this path planning go-to stuff here only works on a terrain with obstacles. So it has its own context, which is required. And also the avoidance, the way two characters, like two human characters avoid, is going to be completely different from how two cars avoid, right? So this is why we've got specific behaviors for that use case of having cars. The rest will kind of remain the same. We'll be able, to physicalize a behavior, apply a force on it, and all the physics engine can take over, even if it's a car. But regarding specific behavior of avoidance or going somewhere, you really want to consider in which context you are. And here the context is having a traffic locator. And you may notice that we got also a similar icon, but with birds, because characters which are moving in 3 dimensions, so moving in the air or in the water, they're going to avoid also in a different way, or they're going to reach a target in a different way. So you also want to have a different context there. You missed the part where I generated the crowd from the traffic. Yeah, sure, no problem. Let's do this again. Let me remove those nodes there. So yeah, if more people were stuck, that's probably a good opportunity to get back to where we were. So as always, we've been creating the entity type. Next, we want to populate the scene. So I'm going to open the population tool and see what we have in terms of options. And one option that we have, especially in the populate in selection part, is create particles around the selected curves. So that's convenient because we also have curves into our scene. So let's first select the curves, like select the actual nodes from Maya with the tool settings still open. And let's press on create particle around the selected curves. And now you can see that your full traffic system is going to be filled with entities. And now you can change, how many characters you want to have. So in my sim, on my side, I had 100 characters. So let's reduce this to 100 characters. And let's so increase the distance between the characters so they are not in collision with each other right away. So I just increased distance. And when I'm happy with this, don't forget that in order to have your characters being generated, you want to press the create button. And as soon as you press the create button and run the simulation for a couple of frames, now you end up with your crowds. So hopefully you were able to keep up now. Great. So indeed, let's go into the behaviors of my cars. So both my taxi and my regular car there. Right now, they don't do anything, but I'm going to drag and drop a traffic go-to behavior. So that's going to be the icon with the car and the targets. I'm going to drag and drop it, apply it to the behavior flow. So now my characters get assigned with this behavior. So let's take a look about the attributes. And by default, we go random targets into the environment, which is totally fine for me. I just want to have people reaching the random target anywhere in the city. I don't want them to converge to a specific point. Great. I also want them to avoid each other and be able to specify a speed on a per character basis. So let's bring the other behavior, which features a car on the icon, which is the traffic behavior. And I want to put these two together, like we've been doing, with the go to and avoidance, like we would be doing with the bird go to and the bird avoidance. So here I want to have both behaviors running at the same place. So I want them to go somewhere random, and I want them to avoid. And here into this system, you can specify what's going to be the maximum speed for the characters, what's the maximum acceleration, deceleration, some noise. If you don't want them to be exactly aligned on the road, they can just have some lateral noise around it. And just by doing so, hopefully, if we run the sim now, we'll get a first traffic simulation running. So let's take a look what's going on here. Here, I've been defining that on this part of the city, I've got a traffic light. So now all this intersection system is actually going to be driven by a full traffic light. So if you run the simulation for a couple of frames, you'll see that the traffic lanes will alternate with each other. As soon as it's turned green, characters will pass. And when it turns red, they will just stop. And then the other lane will start and character will pass. And just leave their lives and do whatever they want to. If you want to change, the length of the traffic light colors, you can still go into the crossing locators here, and you can influence, how long is going to be green, how long is going to be orange, how long is going to be red. So orange or red means that it's time to stop. Green means that you can go for it. Great, awesome. That was kind of easy, right? And for the rest, the junctions here, the characters just handle this by themselves. So they let the priority to the others, and as soon as they are able to go, they just engage themselves. And yeah, here I've got an actual blocking of my crowd. There's a traffic, where does that character want to go? Yeah, okay, they're just letting each other pass. So this is why I'm having a traffic jam. So probably it will be a good thing to maybe change this and say, let's use a traffic light instead. So they organize themselves better. I think I've seen an answer regarding, can you control external objects? Yeah, that's something you can totally do actually. So you may notice that in each of your traffic light system, let's say that guy here, for example, we've got output lights timing, and it's telling you here that's some attribute you can connect on. So that's driven by Golaem, and it's giving you at any frame what's the value of the traffic light connected to the curve called the Bezier shape 9, Bezier shape 6, Bezier shape 4. So here it's telling you that 6 and 4, the value is 1, so 1 means green. So that's probably this curve there and that curve there. So you can have, my object here being connected to the Golaem traffic system, and you can have the shaders or the visibility or whatsoever being driven by this. And you got the two other curves which are set to 0, which means that they are red. And if we run the simulation, for long enough, we may even have some orange. So anything which is between 0 and 1, whatever value which is between 0 and 1 is orange. So you can also drive some orange color if you want to with this. Great. So if we pay attention to the characters really closely, we'll notice that the wheels, they are not turning so far. Here we're just animating the route translation of the character, but the wheels are not actually rolling, or they're not adapting to the steering angle that we're having. So in some situation, that's not really a big deal. But I also wanted to take the chance today to show you how you would control this if you wanted to control those. And that's also a way to bring, to show you the channel operators and to show you how you can use them to just create your own behaviors. So the idea behind channel operators is that if you're not happy with all the behaviors that we provide, we've got plenty, but sometimes you've got some really specific requirements, then the channel operators allow you to fulfill those requirements by designing your behavior yourself. So quick disclaimer about channel operators: they can be really simple or they can be really complicated. And obviously, when it comes to designing your own behaviors, you're entering into another complexity, I guess, of the system. So here we're going to start with just making the steering angle, and you'll see for this one it will be super simple. We'll just have to connect together two nodes. That's going to be fine, and then I'll show you how you can have them rolling. And here we're going to probably need a bit more nodes. And also maybe we can just have some attributes like we can animate to get left turn and right turn lights on the car. So if you want to animate a shader on your car to blink what's the name, turning light, I guess, turning lights, if you want to blink it, also I can show you how you can do this. Great. So if we want to procedurally animate this using channel operators, we're gonna bring into our scene the channel operator behavior. So yeah, the tooltip is kind of broken. The name of the behavior is not displayed anymore on that one here, but that's going to be fixed into the next version. So if you check into your behavior library, that's the one which is next to the spring icon. So you can see there's a T-pose character with a kind of a string attribute and something, we're writing something into that string attribute, and it has a green arrow which allows to write some attributes on the characters. So if I just over mouse upon it, it's supposed to say channel operators, and it drive attributes or bounds using a graph of low-level operations. What a program. So let's drag and drop this behavior. And we're going to use this behavior to make multiple things. So we're going to use it to drive the steering of the wheels, drive the rolling speed of the wheels, and also drive an attribute which would just be the value of a shader regarding turning left or turning right. So where should we put this behavior? Should we put it before, after, or at the same time than the other, knowing that it's going to be like an animation behavior kind of? What would you say? Okay, now people are using short signs to design the parallel. Sweet. So parallel, after. Another guess. So before, obviously. So the idea here is having a behavior which will run at the same time than the other. So those guys are going to drive the entity position. So it's going to drive the speed at which it moves. It's going to drive where it goes, and so on and so forth. And at the same time of having those behaviors driving the character, we want to animate the character procedurally. So we want to get the velocity, the speed from those guys there, those two behaviors. And from that velocity, we want to feed the character. We want to feed the wheels, how fast they will turn, how big they will steer. So it's going to be at the same time. So I'm going to just drag and drop it at the same position than the rest. Once again, as we are already into a parallel, I just have to put my channel operator behavior on top of the parallel operator and just release it. And now I've got those three behaviors at the same time. I can rename that behavior, by the way. I can rename it like car procedural anim, car proc anim. Great. So yeah, let's start simple with just steering the wheel. So let's check the channel operator. Let's select it and let's take a look. Well, you may notice that if you take just a quick look at its attributes, it looks pretty simple. And I was saying like before that it allows to reach another kind of complexity in terms of designing behavior. So that complexity is not apparent right here, right? So what you have access to is just a button called Add New Output Channel. So everything you'd like to drive, it can be an attribute, it can be a bone, it can be whatsoever. It will be an output channel. So here we'd like to drive the orientation of the left wheel, the left front wheel, and the orientation of the right front wheel. So that's two stuff we'd like to drive. So we're going to create two output channels. You can see by default, they are named channel operator output shape 1, channel operator output shape 2. So we probably will have to rename those. It allows us to define which output channel we want to drive. So sometimes we can share channels with different behaviors or with different entity types if you like to. Then you've got a button which allows us to open the node editor for this output channel. So we'll use that one later. We've got a green dot, which allows us to say, I want to enable or disable the computation of that output channel. Sometimes you may want to debug some stuff, and rather than unplugging the whole system, you just want to disabling it. Or you can just remove that entry from that behavior, right? So what we want to do, obviously, is to edit our output channel. So let's open the node editor. You can click on any of those icons here. And as soon as you click on any of those icons, it opened a new editor, new nodal editor, and we can close the behavior editor in the meantime. You can also access that new editor from here, from the shelf. So next to the character with the magnifier lens, magnifier glass, you've got an editor which has multiple nodes connected together as a tree. And if you order the mouse on top of it, it tells it's the channel operator editor, which allows to view and edit simulation channel operators. Great. So let's see what we have in our scene. We've got two output channels, which is going to be the exit point of my graph. So I'm going to design a graph, and the result of that graph will be written somewhere. And where it's going to be written is going to be specified into the output channels. So let's rename those guys. I'm going to rename the channel output shape 1 to steer left front wheel. And I'm going to rename the channel output to steer right front wheel. Great. So let's see what we can do with that node. So it allows us to define first, where are we going to write the value we're going to plug into that node here. So the default value here is a Golaem attribute. So Golaem attributes are just variables you can attach on a character. We're probably going to play with that today. So they're just, random floating values, integer values, vector values, whatsoever that you may want to attach your characters to, add. And they can be used to drive whatever you want to, a shader or visibility or a behavior or whatsoever. So that's just a variable where you store data in. So that's not really what we want here. We want to directly control the steering wheel, the steering tire. So let's check what we have, other options which are available. So we can drive a PP attribute. So PP attribute stands for per particle. It's more like a legacy stuff that we don't use really anymore. We can drive an entity bone, which is interesting because it's kind of what we need to do today. We can drive the position of the entity, the speed at which it goes, the body orientation, the up vectors, the entity traffic speed factor. Well, plenty of different stuff. But what we really want to be able to drive here, to control here, is an entity bone. So I'm going to switch from Golaem attribute to entity bone. You can see that now the Golaem attribute name is grayed out. But instead, I can go into the entity bone attribute panels, which is now accessible. And we can specify on which bone we would like to drive our character. And to be honest, probably didn't need to have 2 output nodes there. I probably could have put everything into the same output. Interesting. Well, let's see if we can, let's do this way for now. And let's see later if we can just combine those two together. So, okay, let's add a new bone output. So here I just created a new entry. So I'm saying, okay, I'm gonna write something into an entity bone. My bone is gonna be, so you have to specify the name of the bone. Then you're gonna specify on which component of the bone you'd like to write that data. So is it gonna be a rotation, a translation, or a scale? So here, trust me, is gonna be the Y component of the rotation. So I'm gonna select rotation Y. And would you like to add the value to the current value, or would you like to divide it, subtract it, or whatsoever, or would you like to just assign it? So I'm going to select just equal. So here I'm saying, okay, I want to control from a set of nodes the value of a bone, the Y component of it, and I want to override it. So final stuff we need to do is specify what's the name of the bone, and to check what's the name of the bone being available, I can use the bone name helper, which is below. So I can just use the slide button here, or if I press enter into the bone name helper, it will show me all the different bones which exist for my actual character. So there's plenty of different ones, but there's one called front left and front right. So that's the 2 I'm going to need. So what I can just do is copy paste those values here, or rewrite those values, make sure that you respect lowercase and and uppercase as well. So here I'm saying, okay, front left Y component, I'm going to write some value in it, right? So we're saying that we're going to control the front left Y component of the rotation. Great. So let's see if maybe that works. So what we can do now is just specify a value, just a static value for now, just to make sure that we are on the right axis, that we are on the right bone, that it's doing what we want. So from, as always, the chop editor, as all the editors, it has a library on the side, which are the different nodes that we can drag and drop and connect together. So there's plenty, but the one we would like to use are input nodes. So we got output, which allows to write the value, and input allows to read the value from somewhere from the simulation. So if I just hover upon the first icon, the first green icon into my library, it's called crowd channel operator input, define an input variable based on a constant, a Golaem attribute, or a Golaem channel. So short is just something which allows to read anything from anywhere. So let's grab that guy here. So that's my input. I can write into the expression whatever I want to. So let's say we write 45 degrees. I just want to make sure that I'm on the right axis. So let's provide a value, static value here, 45 degrees. And let's connect the 45 degrees to the output. So now I'm saying, okay, my front left Y rotation component will be assigned with a value. That value will be 45 degrees. If I run the sim, and let's check the left wheel of my car. If I run the sim, now I can see that my front left wheel is rotated from 45 degrees. So apparently that's what I need. Excellent. So I was saying that maybe we can use that same output to drive 2 bones. So let's see if that works while I'm here. So sorry, I don't need that tool anymore. I can open the node editor. Yeah, great. So maybe I don't need that second output there. Let's go into my output. Let's create a new bone output there. And let's see if we provide front right. Once again, it's going to be the Y components. Hopefully they are rigged the same way. And hopefully I don't have to reverse the value. Let's check. Let's equal it. Once again, we want to replace the value. And let's see what we get. Hopefully they turn in the same direction. Yay, awesome. So excellent. So yeah, actually we can just use one output node to drive two bones, which is great. So yeah, once again here, what I'm saying is into the front left bone, front right bone, which is actually controlling the steering of my character, into their Y component of rotation, I'm going to assign a value. And that value is just a static 45. So obviously, if I run the sim, those wheel orientation doesn't have any influence on the whole simulation. What you really want to do is constrain your rotation to the right value, which is coming from the simulation. So here, all the characters, they have their wheel being turned. So obviously that's not correct. So we'll have to feed it with a correct value now. So probably we want to rename the nodes properly. So that's going to be here, steer front wheels, rather than having just left and right. And well, this one here, I can just, remove it from now. Great. So to end up that feature we want to add, now we need to find a way to provide a dynamic value which makes sense in the situation that we have. So we want, to take the orientation we have from the simulation somewhere. So let's see what we have. So here it's an expression with an auto drop down, and we can see we can set up a double value, which we've been doing. 45 is just a static double value here, or a vector, which means 3 different values there. You can also take a ramp per particle attributes. You can write some Python or Mel. You can use a Golaem attribute, which is what I was referring earlier. So you can read a variable from a character if you want. And you can also use a channel. So you can just let to auto or switch to channel if you want to. It doesn't make any difference. If you just set to auto, it will figure by itself. It's a channel. So that's just to help the system sometimes to figure what it is. But with a channel, there's not going to be any problem. And if we want to check, so a channel is basically data that we are computing internally in Golaem. So, the orientation of a bone, the position of a bone, which frame we are reading right now. So that's something we used when we were doing the archery scene. We are looking at what's the frame being played by the archery soldier at a specific moment. And we use this to feed the fact that we're going to emit an arrow at that exact same moment. So let's see what we have in terms of channels. So once again, you can press N3 while you are into the expression string attribute, or you can use the small button next to it. And there are plenty of different attributes, so we're not going to review all of them. That list is just infinite. So what we may want to check if are there some attributes related to the traffic. So what we can do is start typing traffic into the filter at the beginning, press enter. And we've got a couple of channels appearing here. So one is traffic enabled? So probably returns just a 0, 1 value. Is traffic navigating as a traffic target? What's the target position? What's the distance to the target? Is the traffic turning left, turning right, turning left? Is the traffic braking? And finally, we've got traffic steering angle. So how convenient that data that we want comes from a channel which already exists. And we can use this to feed the actual angle from our wheels. So I'm just going to select this. So just press apply. And here we're saying, okay, what's going to be written into my Y component of my rotation of my front wheels is going to be something which is computed by Golaem automatically, which is the traffic steering angle. And just by doing so, now we can run the sim and we can check. So obviously my character is, that character is turning, and we can see slightly the wheels are turning. If you need to have something smoother, you can just increase the sample count there. but let's pause this for a second. Well, it's pretty, yeah, it's pretty subtle here, but you can see the wheels are turning and they're turning exactly the right angle, which is required them to turn based on what's being computed from the simulation. Great, awesome. And also at any time, obviously you can select a character and you can see what's the current value, which is computed by the system. So we can see here, my input node, so my green node is returning a value of minus 8.6. So turning on the right side with 8 degrees. And it's writing this into my output node. And also if you open the node editor while having your character being selected, you'll have also the value being displayed in orange into every single node that you're having. And you can monitor and follow this and see what they are, how they go, and figure if that's the right value. Okay, hopefully that makes sense. It's 7 on my side, well, 7 past 7. So let's do a, well, except if you got questions, let's see if you, well, let's make a pause right now. Let's see if you got questions, if that makes sense so far. And if it does, then we'll just meet back in 5 minutes. So at 12 past 7, if that's okay. Great. So yeah, see you in 5 minutes then. Hey again. Sorry, I'm slightly late. Okay, let's check the question and answer panel. There's actually one. And also that let Alex come back. Is there a way to make the simulation adhere to dedicated turning lanes for left and right? You mean having character specifically picking a lane so that lane goes to the left side or to the right side? Am I correct? Yeah, okay, gotcha. So you can probably hack it like by making specific curves. So let's say you want to have a lane which is going left. What you can do is on top of your crossings, that what we've been doing here, we've been doing really simple one crossings. Maybe you can have like an additional curve into the system, which is going from your main lane to your other lane, and which is making just a specific pass, so from the left and from the right, and have it like a specific line to turn left or to turn right, and have it just a one direction lane. So you can probably hack it to the system. It's not like native, or it's not something which you get from the just two curve intersection. That's something you need to add on top. That's something I think I've seen it in production before. I think that was the way it was done, but I never tested it by myself, to be honest. If it's like a real requirement, that's probably something we can speak about in a support ticket. Alex, are you back as well? Great, good. Okay, so let me rename my node here. That's traffic steering goal there. Yeah, I tend to try to name my node like every time I can, because that node editor can become pretty complex pretty fast if you had nodes and node drop stuff, and at some point you have to dive into that scene again later, and you never know exactly what is doing. So putting names which make sense is actually a good idea. Great. So, okay, now we've got left, right steering control. Let's say we would like to have rolling controls, forward wheel rotation, right? So let's go into our editor, behavior editor. Let's go into the channel operator, channel operator behavior, cap, procedural, anim. And yeah, we've got our output channel, which is steer front wheel, and has deleted the other output channel. Now it's just saying no output channel. So I've got plenty of ways to actually tackle this. I can either create an output channel myself from the library, and I can connect it here, and now it becomes active. So that's one way. Or let's say you're here, what you can do is just remove that entry and create a new one that will create a new output channel. So whatever you like here. But the idea is we just want to have a second red node into the scene. And we want that red node to be connected to the channel output behavior, channel operator behavior, sorry. Great, let's, so that's steer front wheel. So we're gonna call that one roll wheels. I'm not really sure if that's the right verb here. Oops, wait. No, I renamed the damn. I renamed the behavior instead of the node. So that's proc anim, cap proc anim, cap proc anim. So that was correct. Okay, now close that one here. So that guy here, roll wheels. Great. Okay, so same than before. What we want to control into that output here is going to be once again an entity bone. So let's switch the channel from Golaem attribute to entity bone, and let's create 4. Not sure why I'm losing the focus, but if like me, when you press on the add new bone button, it just disappears to something else. You can just re-click on your output node. I have to check this. So I'm going to create 4 different entries, one for each wheel. And I'm going to go into my bone name helper. So what I want to have is front left roll, front right roll, rear left roll, rear right roll. Let's press apply. And I'm going to copy those or rewrite those into my bone panel. So front left roll. Right. Let's copy this here, front right roll. So if any of you guys are familiar with Houdini, by the way, channel operator is kind of inspired by Houdini. They also have something called channel operator, which allows you to, make your own graph to compute stuff and write it into a channel. So that's something quite similar. And really, that's when you need to do something more advanced, more specific, something that we haven't really thought about before. That's usually the right way to do it. So rear left roll and rear right roll. So, okay, front left, front right, right rear, left, oops, sorry, left rear, left rear, right. Great. So here, the axis I want to touch is going to be rotation X. So the default value is going to be fine. And once again, I want to assign the value. So I want to replace this with an equal here. Great. So yeah, let's see how we drive this. So yeah, bear with me because we're going to have to drop a couple of nodes, but also that will be the opportunity to see what's in the box, to create all of those. So maybe intuitively, something we can think about is how much, well, what we want to provide here is an angle. So that's going to be degrees. And we want those degrees, to be aligned with what the current speed of the character. So the character is going to move at every frame, and we want to take into account how fast it moves. And we want to find a way to to convert that speed into angles, right? So it's probably time to go back into your mathematics courses from high school, because that's probably something we're going to need today. So first is we need to come with the speed of the character, right? So we need to grab the speed from somewhere. And as always, when you need to read something from the simulation, you need to bring an input node. Let's rename that input node entity velocity, right? So, oops, sorry, that's the name of the node and not. Okay, that's entity velocity here. So, okay, let's try to fetch the velocity of the entity. So let's see what we have once again from the helper panel. So let's see if I type vel for velocity. It comes with plenty of different velocities, and something I'm interested in with is my entity velocity. So here, entity velocity, pelvis velocity, they are the same. So pick whatever velocity you want. Great. So entity velocity here, and well, if we want, we can plug it like right away into the roll wheels. Obviously, that's not what we need to do, because here that's a meters per second value, and we need to convert it into an angle. But we can check if at least it's providing the right value. So we can see here, if I run the simulation for a couple of frames, that first thing is I end up with a vector. So my velocity here, and if I was looking into the documentation, I would figure this as well. So my entity velocity here is a vector. So it's providing me with a velocity on the x-axis, on the y-axis, and on the z-axis. So probably I want to convert this as just a number. I don't really care if I'm moving on the left, moving on the right. I just want to know how fast I go, and I want to have this as a meters per second stuff. So if we want to convert, this vector, this velocity vector into one value, what we can just look at is what we called the norm of that value. So what's the length of that vector? So the entity is here, then it goes at 1 second after it's there. So you've got this vector, 3 values which define the velocity. So what you just want to know is what's the distance between those 2 points. Entity at frame 1, entity 1 second after, what's the distance of that vector? So how many meters it has went through. So it means that I need to bring a mathematical operator that we call the norm. So the norm just returns you back the length of the vector. So if I want to apply a mathematical operation, whatever mathematical operation I want, I can jump into the library and I can see there's one with the plus, minus, multiply, divide sign. So I can just drag and drop that one here. And once again, if I put it, on the flow, you can see that the flow brings in, well, it blinks, it becomes kind of bold. And if you release, it used to be bold. I don't have it anymore. Okay, it used to be bold. Else, just delete the connection, and you can use left click from a connector to another to define your operation. So now we've got the entity velocity, which is connected to an operator. So we're going to rename that operator entity velocity norm. Great. And we want to go into that node, see what it has as an attribute. So we can see it as channel operator attributes. It has an operator dropdown. And here from the dropdown, I've got a couple of mathematical operations I can apply on my previous value here. And I'm just going to select norm. So now I'm taking the vector and seeing what's the length of the vector. If I rewind the simulation, play for a couple of frames, now I can see my vector gets converted into one value, and what that one value is just the distance that we'll go through. So at the moment, we go at 1 meters 21 per second. And if the simulation goes faster, it reach 7, 8 meters per second. Great. Okay, excellent. So now we've got my speed of my character, but we need to convert this as angles. And obviously the angles will depend on how big is the wheel of your character. So anyone is familiar with a car wheel size? What's the size of a wheel on a car? I have totally no idea. So let me check. That's probably like, I don't know, 50 centimeters or something like this, right? Let's check where's my actual character here. So obviously, if you got big wheels, they need to turn slower than if you got small wheels to go at the same speed. So that's my wheel here. Let's create a box next to it. And let's see what's the size of it. So we'll be really accurate there. So nobody knows what's the actual size of a wheel, right? I don't get any answer. Okay, so that's probably, I don't know, 0.7. Yeah, okay, 0.7 is about right. Okay, let's pretend a wheel is 0.7 diameter here. So let's see if some of you guys remember your high school courses from mathematics. Does anyone can remind me how do we compute the perimeter of circle? So here we've got a circle. So what's the length of all of this? How many meters it is? I know programming pro tip for that. Googling it. Yeah, correct. Perimeter for a circle. Let's see. Well, I do know the answer, but PR square. Yeah, PR. I think it's PR square gives you the actual area the circle. If you just want to have the perimeter, yeah, P2R, that's the right value here. So P2R means like you want to take the P number, multiply it by twice the radius. So it gives you like the diameter. I'm not gonna, I could like compute it with the graph here, but I'm not gonna make it harder. So I just take 0.7, which is 2R, multiplied it by like P, and that gives us 220. So 220 will be the actual length of my wheel. So let's put this somewhere. Let's create a new input into the graph. And well done for reminding this. We're gonna say that's wheel perimeter. Normal car ties is between 205 and 225. Yeah, not so, yeah, okay. That's not so bad. Yeah, I went the scientific way, but obviously you can Google just the answer and that can come with the right answer. So here in my situation, the value I want to provide is 220, so 2.2. So that's my wheel perimeter. So that's the length of my actual wheel. And what we want to do, obviously, is to figure, according to the speed, what's the ratio of the wheel perimeter that we went through. That gives us a ratio that we can multiply by just degrees, and we'll get degrees then. So let's rename this. So wheel perimeter is correct. And now what we want to have is a perimeter per second. So I'm just bringing an operator. So I'm just going to divide that norm. So bringing the norm, so the speed of the character, how fast it goes, how much it represents from the actual parameter of the character, and let's plug it out into the outputs. So what the name of this node here is probably something like perimeter per second. Great, and let's run the sim so we can debug the value. And yeah, as we go, no. Sorry, there's something wrong here. Yeah, sorry, I forgot to change the sign here. It's adding the two values together. Obviously, I don't want to add the two values together. I want to divide one by another to know how much of a wheel we are turning at the moment. So I want to use the divide sign. Great. Yeah, so it means that now we're going at 5.46 meters per second. And my wheel is 2.2 meters. So it means that per second, my wheel is turning 2.5 times per second. So that's my perimeters per second. So now I need to convert this to degrees. That should be pretty easy. So a complete circle is 360 degrees. So we just have to multiply that value by 360 degrees. That will give us how many degrees per second our character is actually moving. So let's break that connection. Let's bring a new operator. We're going to call this degrees per second. And what I want to connect it to is probably just a new input, which will be it's just 360 here. Oh, can't rename. Okay, I can't name it, just 360. So that's going to be just perimeter degrees then. So, okay, just a circle is 360 degrees. So we want to know how many degrees we've been going through in just 1 second. So we're just going to multiply the perimeters per second by our perimeters degrees, connect this, and we'll be nearly done. So here, if we are, we're going at the speed of 5 meters per second, which means that the wheel needs to turn 2 times and a third per second, so 2 times and a third represent 817 degrees. And obviously here, we are not requiring a per second information. We need to have a per frame information. So we're going to update our characters on a per frame basis. So we need to finally divide this by a frame rate. So the frame rate right now is 24. So what I can just do if here I'm lazy. So what you can do is probably, you know, add a new divide operator connected to the frame rate, etc., etc. But here I'm lazy. What I can just do is just take 360 degrees and divide it by 24. Let me check how much it is. Divided by 24, that's 15. So, you know, rather than doing everything here, what we do here is 15 degrees. So that's per meter degrees per second, per frame, pardon, sorry. And that's degrees per frame now. Okay. So yeah, I was just lazy here, so I just cut my operation. So let's rewind the sim and let's run it. So right now my characters goes at 5 meters per second, which is 2 times 0.3 the length of my wheel. And per frame, turning the wheel entirely is 15 degrees. So that means that my character now needs to move with, well, the wheel needs to move forward by 34 degrees. So, okay, we're good. We'll write this into the wheels. And we're probably almost right, but I already know that I'm missing something. So let's check a look at how does the simulation looks like for the character. So the character is stop. So the wheel is not turning. So that's good. And as soon as we move in, it's not really turning either. But I know exactly what's my issue here. 27. So it's, yeah, it's actually turning, but not really fast. Okay, so I know my problem. So here you can see at frame, where am I? So I'm frame 78. And you can see that the degrees that I'm assigning to my character is 27. And then, so it means that the wheel is turning by 27 degrees forward. If I run another frame, now my angle is 29, but I have not added those 29 degrees to my previous values. So this is why here I'm not seeing my wheels turning. I'm just, you know, slightly changing the angle. But what I actually want to do is accumulate the value for the whole duration of the shot. So every time I'm adding a new value, it's added to the previous ones. And it just makes my wheel moving forward. So we need to fix the graph once again, just add an extra node. So we're gonna go back into the channel operator, and rather than connecting directly our angles into wheels, what we want to do is accumulate the values. So I'm gonna bring an accumulator here. I'm gonna plug it in between. So the accumulator, as the name tells, allows to remember all the previous few values which have been provided. So all the previous values, you're going to specify how many values you'd like to remember. So let's say the duration of my shot is 500 frames. So I'm going to say, okay, I want to remember 500 frames of my simulation. So here now we're going to buffer 500 different values. And as soon as we fill that buffer, we're going to forget the previous ones. And what do we want to do? Do we want to average those 500 values, or do we want to get the max, get the mean, get the oldest one? So what I want to do here is sum them up. So I want to remember all of them. Yeah, sorry, I should have answered the question, but yeah, let's sum them up and let's check what we get now. Well, they're moving too fast, so I don't really see them, but and also, well, the wheel is, it's like almost a perfect cycle. Right? There's just only that internal stuff here, which allows us to see if the value is correct. But yeah, I can see it's turning. And when they stop, it's not turning anymore. So great. And yeah, well, we can see at any time for our characters what's been stored, and we can see, how it's accumulated those values and how they are, summed up, and what's the final front wheel rotation which is provided. So at the end, we can see we provide an angle which is 5,300 degrees onto the character. So yeah, I know that was, kind of next level compared to what we've been doing. But even if you were not able to follow this properly, because maybe you're bored of mathematical functions and that kind of stuff, the idea was just, I wanted to show you that you can extend the system in pretty deep levels if you want to. Like you can create your own graph, make your own computation stuff, and write this wherever you want to. So here we write it into a bone, but we can use it to look at other characters. So that's probably something we're going to do. We're going to have pedestrians, and maybe they will look at cars which are too close to them, maybe follow, or you can use that to drive the light for turning brake, turning light, or blinking the brake light or whatsoever. So you can take all those different parameters, compute your stuff, make whatever you want to with them, and write them wherever you want to, and benefit from that. Maybe you can drive a trigger, maybe you can drive an attribute, you can drive a bone. So that's the final idea here, is that the system is fully extensible here. My solution would have been to ask a rigger to add an auto row to the car rig. Yeah, sure, but you wouldn't have it into the crowd system, because if it's within a specific rig, when you're going to convert it into Golaem, you're going to lose that rig. You'll just end up, with the bones and with the skinning. So what we've been doing here is reproducing what your rigger would have done on a rig, but rather than using Maya nodes, we're using just Golaem nodes, so they can drive a Golaem character, whatever the context. But well done following all the stuff. Should I take just 1 or 2 minutes to show you how we can make left turning, right turning lights? Yeah, let's do it. Let's make just another one, which will be like way simpler than what we've been doing. But I just want to show you how you can, have a blinking 0101 animated value here. So, and also because it brings new nodes that we haven't been seeing so far. Let's add a new channel into our car procedural anim behavior. So we've got something which is controlling the steer front wheels, which is making all the wheels rolling into the right direction with the speed, according to the speed. And we're going to add a new one, a new output channel. And we're going to need 2 this time, because turning left, turning right will be different informations there. So let's add 2 output channels. Maybe we'll do just, I'll show you how you do one, and you have a chance to replicate the system for another. So let's rename that node. So channel output 1 will be left turn light blink. Great. And once again, I didn't rename the right. Damn. Okay. Left turn light. Great. Okay. So probably first information that we want to have is my character about to turn left, or is my character about to turn right? If you remember, when I was looking at the different traffic channels, there was one which was named is turning left, is turning right. So we probably want to benefit from that. We probably want to use that data. That data, we created channel for it, because that's not something you can easily extract from the simulation. I mean, you can't really look at what's the current position or orientation of the character to know if it's about to turn left. Maybe it's in a straight lane, and at the end of the straight lane, it will turn left. So that's not something you can figure by yourself. So we provide this as a channel data. So left turn light blink. Let's bring a new input node. So just a regular input node. And once again, if I press enter while I'm in the string attributes, I can open the all attribute panel, or I can just use the helper next to it. And once again, I can start typing traffic. And I get a is traffic turning left channel. So let's double click on that one here. And let's connect it right away into our left turn light blink. And I try to select a character which is supposed to turn left in the simulation. So that guy here will turn left. So that's convenience. So let's see what's the value of this. Is about to turn left. Let's see if I run the sim. Okay. So you can see that when the character is here, its value of is traffic turning left turned from 0 to 1. So that's just a flag which says, okay, I'm not turning left, I'm not turning left, I'm not turning left. And at some point when it goes back to 1, now it's turning left. Okay, so we've got like a 0-1 switch. And I guess that once it has turned left, now it goes back to 0. So that's something you can use to drive a shader or drive whatsoever you want to, like a light or whatsoever. But that's just a 0-1 value, and probably your shader just expects it to be, should I alight, should I stop? And obviously when you do a turning light, it's blinking. So what you may want to do is use Golaem to make the blink and enable that blink only when that is traffic turning left as a value of 1. Great. So let's extend that graph. So second thing we want to do, well, let's rename this. Let's rename this is turning left. And what we want to do is define that blinking. So we want to create a procedural animation here, which is just blink, yes, no, yes, no, yes, no, yes, no, and select how fast it will blink, design everything ourselves. So let's create a new entry, which will be our blink animation. So let's rename this blink animation. And the only way we can create an animation with any of the nodes within Golaem is by using a ramp. Remember when we were doing that fight sequence, we had the Romans, which were all informations, and we wanted to add some noise on their wrist. We're able to use a ramp to provide a random value, and by default that ramp was animated, so we could see the character has a slight nose on the wrist. We're going to use that exact same controller, but here to drive just a blink value, so 0, 1, 0, 1, 0, 1. Great. So here, rather than using an expression, a channel, or whatsoever, we can see that within the dropdown that we can also use a ramp node. So once again, I can just stay to auto or select ramp, would not make any difference. And I can create a new ramp in my input node. Remember the last time we were using a ramp, the way to address it, to link it to the expression, was to look at the name it has. So it's called ramp, bracket, bracket, and a 0 in between. So we're going to use a specific syntax once again, which is part of the documentation, which is hashtag ramp in lowercase, the index you'd like to use. So here the index I want to use is 0. So I want to use the ramp at index 0 and hashtag. And this way I'm saying, okay, this attribute will return the value of ramp 0, and ramp 0 is going to be this node here. Great. So let's jump in that ramp. You can find it now from either the tabs above there, your node. So you can jump into it, or you can use the arrow here and it will select your ramp and show it to you. So I prefer using the actual tab. And here I can use my ramp to, design my actual blinking. So let's do something simple, like just like a control like this one here. So this will return 1, this will return 0. Half of the time it will be 1, half of the time it will be 0. So that's my actual animation. If you wanted to make like super nice, you can make sure it's aligned on the 0.5, so they have the same weight, the same length. So it's really up to you to design how your blink is looking like. So next we're going to say, okay, is it randomized per entity? So not really, we don't want to randomize this per entity. Is it dynamic? Yes, it's dynamic indeed. And the way it's going to be evaluated is just, it's not going to be noise. So noise means that we may change direction all the time when we're going to evaluate the curve. So here, what we want to do is run the curve linearly and loop it. So I'm going to say I want to loop it. And then you decide what's the duration of this. So here, 1 second means half of a second we'll have. Duration is 24 frames. So 24 frames is 1 second. That means that half of a second it will blink and half of a second it will turn off. So up to you to decide how long it is. Let's say it's going to be 12 frames, so half of a second. So it's a pretty fast blink. Let's check what we get. So rather than plugging the is turning left here, what I can do is I can plug directly my ramp. Obviously, I will need the two of them. And if I run the sim, I can see I've got, well, I don't have exact values there. So I've got 0.98, and I've got also interpolation because my ramp was not exactly rightly designed. So, okay, that's pretty unfortunate here because really what I want is to have just 0 or 1, and I don't want to have intermediate values there. So what we can do is use once again the mathematical operation. So let's call it round blink and aim. You may have figured what we're going to use as an operator here is going to be we've got one almost at the end, which is called the round, and round will just take the closest integer value. So if we are at value of 0.98, we're going to round it to 1. If we're at 0.1, we're going to round it to 0. If you're at 0.5, it goes in what direction? I'm not really sure which one. Okay, I have to reconnect everything myself. Never mind. So let's select my node. So say, okay, I put my ramp into my round. So I forgot to select it. So now it's a round. Put it into my Golaem attribute. Okay, now I got 0, 1, 0, 1, 0, 1. Great, excellent. And now what I want to do is just enable it only when my traffic is turning left. So remember, this one is returning 0 or 1. So all we just have to do is multiply this value. So if it returns 1, the ramp will be displayed. If it returns 0, the ramp will just stick to 0. So let's just add quickly a multiplier. So multiply operation. So I just call it enable blink. Multiply and connect those two together and that one here. So it means that now when I run the sim, I've got 0. When my characters will turn left, now it's turning left. You can see that now I've got the blinking going on 0, 1, 0, 1, 0, 1. And then, okay, we stop turning. So now it turned back to 0, multiply this by the ramp, and the ramp just goes back to 0 and it's not blinking anymore. So like me, you may have an error into your script editor. So it's saying that right now we're not writing this anywhere. It's true that we're computing all those data, but we're not writing it anywhere. It's just computed just for fun. So it will be, your job to define where you'd like to write it. So if you want to feed an attribute, if you want to feed a shader with this, you can just write it into an attribute and so on. So there's a couple of tutorials which address that specific part. Here my character don't have the right shaders, so I won't go further, but that's just to give you an idea. I can see there's a question. Let's say in this town people not only use the lights, but they even do it before actually turning left. Can we get a value from the future? Well, not really. That channel here, or can we? Wait. Let me check. What do we have in terms of entry? Maybe we've got, the trajectory of the character, traffic. Let's see, traffic enabled, navigating as a traffic target position. Well, not really. So if that was something which was required, to be honest, that's something we have from the beginning. When we launch the simulation, we know exactly which path we'll follow because we analyze the full graph. So that's probably something that we could provide, like the complete trajectory or the next, we call this local target. So local target will be the next position we want to reach after the next intersection. So as soon as you reach and you just went through an intersection, we'll have something called the local target, which tell you where you should go at the next intersection. So that's the amount of future we can see for each character. So yeah, as soon as you went through a crossing, we can tell you at the next crossing what you can do, what you will do. So that's probably something we can provide as a channel. That's just something that's just something that nobody asked. But if that was supposed to be like a real stuff that you will need, just let us know. Having a channel for us is just a matter of minutes, and it gets then deployed into the next release. So we're just populating that channel box with stuff that we think will be interesting, or stuff that people customers are actually asking. The is turning left, is traffic braking is stuff that which has been proposed by customers. I think that was the CrowdTD from Rodeo FX, by the way. Okay. What time it is? It's almost 8. What a great moment to make a break, to make the half session break, especially because also the blades are gonna close in 5 minutes, and they're gonna make a hell of a noise. So let's make a break now. If you got any question, let me know. Put it into the chat box. And I address those right after. Where can we find it? Oh, okay. I guess that's related to the previous questions. Yeah, put it into the chat box, and else see you at 8:10, so in 15 minutes. Oh, and wait a minute. There's a poll before, and probably we can launch the poll now because we are done with car traffic system. So yeah, whenever you got the time, feel free to answer the poll, just so we can know how far you were able to go, and well done if you were able to go through the full system. Okay. Just let everyone gather back. Just wait a couple of seconds before we move on. Let me check question and answer box. This would be great as an operator to offset the time we get a result of an attribute. Huh. Yeah, to delay. Yeah, that makes sense. Let me think about, do we have a way to have this somehow? Yeah, let me write this down. Makes sense. I have to check if we could hack it with the current nodes, but indeed that makes sense to have a way to delay some attributes. Maybe we could do that with the accumulator somehow. I have to think about it. Delay attribute value. And probably, so okay, the question has been stated as answered, but what happens in the meantime? I mean, if you delay, does that mean you return 0 in the meantime? And if the value changes, it's just like delayed by 10 frames and you get, yeah, probably right. Yeah, let me think about it. And if it comes to the release, we'll let you know. Other questions regarding what we've been doing so far? Off-topic questions. Well, you know, I can take a lot of off-topic questions. So what I would probably advise for now is if you got any off-topic questions, just send us support questions on support.golem.com. Else, you know, I'll spend my time answering questions which are not the topic of today, and that's not going to be of interest of everybody here. Okay, any other questions regarding what we've been doing so far? Or are we good? And should we head pedestrians here? If you didn't get the URL when I was speaking about the support form, it's support.golem.com. We're probably going to put it into the chat box. Feel free to, you know, send your question here, provide context about what you're doing, and you know, we provide you with a completely defined answer. Okay, so great. Let's move forward. Let's get that scene better. If you're catching up like right now, if you're arriving right now, no problem. You can just, you know, ignore the fact that there is some traffic into the scene, and we're just moving to heading pedestrians into our simulations. So I'm not gonna have pedestrians, you know, everywhere. What I probably would like to do is maybe make 2 blocks. I'll make 1 block here, 1 block there, and we'll see how my characters can cross that intersections there, right? So let's start by making, so here I want my pedestrian to know about the environment. So I will start making an actual polygon, which will be my ground on which my characters will be adapted on. So probably let me change the color of this for, let's put it darker, and I'm gonna create my sidewalks on top of it. So let's make a polygon. So once again, I'm not really like a good modeler, so I'll do my best here, and let's assign it with a new shader so it has the right color. So I'm gonna, you know, kind of approximate what I have, and probably I can grab just a couple of vertices here to make it follow my road network. So I'll let you, you know, do your ground system. Don't do it for the whole city, obviously. I really am not good with modeling. I'm such a pain. Let's grab those as well. And what we'll do, so let's make the overall shape of a block, and I'll add afterwards a building on it, just you know, in the middle, just to make sure that I've got the right avoidance zone. And let's make it big enough so I can get up to the sidewalks, which are going to be here. But you know what? What I'm also going to do is probably change my crossing size as well. So I want my sidewalks to be right there. Great. So let's make the other block. I'm going to create another plane. Here, assign my second surface and scale it. Okay, great. Yeah, here it's way above the ground, but it would be great if you have it at 0 at the end. I just you know, the time I'm actually drawing it, I put it above everything, but at the end I'll just align it at the same 8 than the rest. So okay, let's put it back at 0 here, 0 there. Let's avoid Z depth by moving this slightly below. Great. And finally, let's make some buildings. Oh, and also don't forget to make a pathway between the two zones. So let's create our walking crosswalk. Not really sure of the word. But yeah, let's connect the zones together, else my characters will not able to go from one zone to another. Okay, and let's finally make some proxies for buildings. So my characters don't move the whole way in the zone. So that's going to be my building in that block there. Let's scale it slightly. It doesn't have to be, you know, the actual real 8, at least it just has to, you know, represent an obstacle into the scene. And let's duplicate it. Oops. Well, let's save the scene, actually. Academy 22. No, that's the reference button. Duplicate. Let's put it here. Okay. Maybe. Okay, not so bad for someone who's not an artist. So what I ended up with is some geo, which I'll use for my characters to walk around. That will be the zone which will be available. I made some building just, I made some, building proxies just to make sure that they don't navigate in the middle here. And I also connected the zones with a polygon. So at least if my characters want, they can go from that area, that block to that other block, and we'll try to make them avoid the different cars, hopefully. I'll let you take a couple more seconds to do something similar on your side. If you don't have any, car traffic, you're catching up the demo, the session right now, no problem. Just make 2 blocks, connect them together, and we'll pretend that there's a traffic light here for you. Okay. And let me check the poll, by the way. Well done. Most of you guys were able to get the traffic working, the behaviors working, and a fair amount of you guys were able to get procedural animation working on cars. So yeah, well done. I'm proud of you. Okay, so now that we've got our setup, remember what we need to do. As soon as we've got characters which needs to avoid some stuff into the scene, we need to take this into account and create a terrain with a navigation mesh. Remember, navigation mesh is something we actually used when we were doing the charging armies, because we had obstacles into the scene and we wanted the characters to be able to take into account those obstacles. So this is exactly what we're going to do. We're going to process that geometry to specify where my characters are allowed to go and where they are not. So everything which is a static obstacle will be taken into account and will be removed from the available zones. So let's select all my geometry on which my characters will evolve. I'm gonna just group it. Let's call it city block. Okay. And with those meshes selected, I'm gonna open within Golaem the nav mesh creator. So the nav mesh creator allows you to provide some parameters like step 8, radius, clearance, slopes that you can go. So those are set up for human-sized kind of characters. And with the environment selected, I can just compute and save. So I'm going to create a new file for this. I'm going to put this into Golaem environments, and that's going to be my city block terrain. So it takes more or less time depending on the size of the environment, but at the end, when it's done, it will create a terrain node. And in red are going to be the limits of your environment. If we take a look into the scene, we have still the GLM environment group. Let's close everything. Which is holding the way the characters, the car system is working. So my terrain does not influence at all my traffic system. And now I've got also my actual terrain for my pedestrian to be spawned on and to navigate in. By the way, if I want, I can even remove my cube blocks here if I don't want to have them anymore. I can just hide them. If I've got, my red borders, they are defining the actual zone of my environment there. Great. So what if I want to populate that city blocks with a bunch of characters? So first we need to load a bunch of characters. So yeah, let's just load one type. If you want afterwards, you can load the other type. So load the man and or the woman character, up to you to decide which one do you like to load. Here I'm going to use the casual manlight, but they all rely on the same skeleton, so no big difference. So I'm going to open the shaders as well to have the visual diversity for my character. Let's see, where's my man character? Yeah, it is at the middle of the scene. So let's remove that guy. So, okay, we've got our entity type. Let's rename this like pedestrian type. Great. And let's populate the scene. So you may notice that we've got a really specific shape here. Let's say we'd like to have characters all around. Well, what we can simply do is, the simplest approach will just be, you drag a box and you put that box just above your area. And, as the tool knows about the zones which are available or not available, it will make sure that you're never going to generate characters outside of available zones. So here I've been heading 1,000 characters, which is kind of a lot. And you can see in that situation, we are not generating characters in areas which are not available. So here it means that from first frame, I'm going to generate characters which will be on the pedestrian sidewalk. So what I can also do is probably draw a specific shape to avoid this. Or let's play with one we haven't played with. Let's say I would like to populate characters on this plane here. I can also select the geo, go into the pop tool, and I can use the populate in selection, which is using selected mesh. So selected mesh means that we're going to take a look at what's the current selection here. And we're going to create a population tool, which is exactly the size of that selected mesh. So means that I can create actually two probably. I'm going to put, I don't know, 200 characters there. Make sure that you are not populating cars, because at the moment we are populating both pedestrian and cars. So that's probably something we don't want to do. So let's remove the car here. We just want to populate the blue entity type. So the blue entity type is pedestrian types. Let's provide them with orientation noise. So they start with different orientations. And let's also provide them with some distance so they're not too close to each other as soon as simulation starts. So 200 characters in that area here. Let's run the sim. Great. Now we've got our 200 characters spawned around that city block, and we can probably do something similar for the other city block. So let's select that block here. Let's redo a mesh surface. let's specify that we'd like to have 200 characters, that those characters are not going to be car characters that have random orientations. Let's provide some noise, and let's provide some distance as well. Sweet. Here we go, 200 more. Great. So now I've got my city block, my traffic system, fully independent. And we'll have to figure a way to make them crossing. Great. So let's see. We would like them to obviously assign some behaviors. So let's go into the behavior editor. So we've got our cars. The cars set up are actually propers. So let's go into the pedestrian now. And what we'll want to do here is we just want them to hang around, pick random targets, and reach that random target. So casual setup, right? We want to apply a go-to behavior, which set up to random. And you know what? Actually, before plugging it directly, I want to bring a loop operator. I'm not sure if we've been playing with this one. The go-to behavior, as soon as it will reach its target, it will just stop. So I don't want anyone to stop into my simulation. I want them to walk all the time, except if there is a car they need to take into account. So let's bring a loop operator. Let's put the go-to behavior into that loop. So that means that my characters will go to, and as soon as they reach the target, they'll just pick another target again. Let's bring a parallel operator. So we can put the go-to and the loop within it. Let's make them avoid each other. So let's bring an avoidance, and the avoidance, we want to release it when we are on the parallel. So we want to loop that go-to, and at the same time, we want to avoid the other guys. So that's the setup I'm looking for. And let's see what we get. So let's maybe add more frames to the sim. So for now, they're not avoiding the car, so we'll have to work on this after. But at least we've got, maybe that would be fun to trigger some physics at some point, by the way. But anyway, we've got characters going somewhere. Fair enough. And avoiding each other, avoiding the obstacles in the scene, except the cars, and picking a target. And while all the simulation will run, they'll just keep running again and again and again. Fancy. So let's now add some animation to those guys. Right now they're not, they're T-posed. So remember, what we want to do is bring a locomotion behavior. So locomotion behavior is a way to adapt animation based on what's required from the navigation and the go-to. So we're gonna bring that locomotion here. We're gonna put it in parallel with the rest. So at the same time that we're going somewhere, that we're avoiding the other guys and the obstacles, we're gonna play some nice animation on top of it. If you double click on that locomotion behavior, it allows you to specify which motion clips you'd like to assign to that behavior. So we're gonna expand into the Golaem character pack, go into Golaem motions. Then you got plenty of different motions that you can assign to the characters. And we've got a locomotion directory that we can just expand. And let's grab any single motion from that directory. So that's all the different stuff the characters are able to do. So they're able to walk at different speeds. They're able to turn on the right side. They're able to stand, to run, to stand and turn while they start an animation. So let's grab them all. Open it. Let's reselect the locomotion and just allow mirroring on any animation, which is turn. So every time you're having orient or turn in the name of your motion clip, let's enable mirrorings by clicking twice on the orange circle next to the clip until you reach the full orange color on both sides. So it means that we're running the original animation and the mirrored version of that animation. So there's actually 8 clips to mirror. And great. Let's run the sim. So, okay, now we're running the sim. The characters they are walking, being kicked by car, being in collision with car, but they're walking, go on the sidewalk, avoid each other. And yeah, play a nice animation, adapt to the ground. So final step here will be obviously to take into account the traffic. Great, sweet. So let's rewind the sim. What's the error I'm getting? Oh yeah, that's because I've got a graph in my car system, which is not connected to anything. Yeah, the blinking traffic light, the turning traffic light stuff, we don't write it anywhere. So I'm just gonna disable it, left turn light blink, so I don't get the error anymore. Okay. So I mentioned in the past that navigation mesh obstacles, they are from static obstacles. And static obstacles, we know that we can go really close to them, and we know that they are not going to move. And I also mentioned the fact that we can bring into the simulation dynamic obstacles. So here in the situation that we are right now, would like to have an obstacle which is blocking the characters as soon as the traffic light is set up to green, and we want to remove it as soon as it goes to red. So we want to have something which is animated, like a dynamic obstacle which is animated and which will be controlled by the traffic lights. So we're going to bring just a geometry in the scene, and that geometry will be what's going to be used to block the characters. So if you missed the previous step regarding locomotion, to get the characters moving properly, to have a nice animation here, as we've been doing multiple times on previous simulation, I've been using a locomotion behavior. So I've been drag and dropping it, assigning it to my characters so they go somewhere and they loop their position, the target position. They're going to avoid each other, and they're also going to play a locomotion set of animation. I've been driving my locomotion by some motion clips, and I just apply some mirroring. Okay, so let's move forward. So what I want to do here is add obstacles. So let's add obstacles like right away. So I'm gonna draw a box here in my scene. It will just act as a wall. So let's scale that wall so it's big enough for the characters not to cross it, and which is at least the width of my crossing walk here. So this is going to be where my characters are going to be blocked. Great. So let's put one here. And let's put one on the opposite. Let's align it properly. Awesome. And it's going to come here. Great. So those are going to be my side blocks. This is side block left, and that's going to be side block right. Great. If I want to turn them into a navigation obstacle, I need to first select my geometry. I can go into my Golaem menu. Once again, this is not something we use all the time, so it's not into the shelf. So select the geometry, go into the Golaem menu, and then you can go, I think that's, yeah, that's below the visual feedback. So almost at the end, just before the create references buttons, you've got something called external entity locator. So external entity locator means that you've got an object which is external to the simulation, and you would like to take it into account to avoid it. So let's assign it to the characters. So we can see that we end up with a circle which is really big. That's just a display. This is not exactly what's going to be avoided. So let's actually change the size of this. So let's go into the external entity locator. So we can see it as a max voxel by per axis slider. So it means that that geometry will be approximated using voxel. So we're gonna, divide it as voxels, 5 maximum per axis, and that's gonna act as an obstacle. Here, in terms for the display, we can just say what we want to have is the smaller bounding box divided by 2. So now the locator is just embedded into that shape here. So just to change the sign mode to smaller bounding box divided by 2. Up, let's go back to my shaded view. And let's create an external entity for the second one. So once again, I can select my geode first. I can go into the Golaem menu. And right here, I've got a menu called, I've got an entry called external entity locator. And if you got a geometry being selected while you create that node, it will create for you automatically another external entity. So once again, we can set it up to smaller bounding box radius so it doesn't bother us for the visualization. So let's take a look how the simulation looks like now we've been adding those nodes. You can see all the characters, they are converging, but you can see that they are slowing down themselves. And well, yeah, they're even like kind of hesitating because it's blocking them, but we are not saying to them that they need to really stop when that guy is here. So they're just gonna gather and go crazy here, making some around themselves. So obviously that's not something that we want. What we want to say is, as soon as that guy is visible, well, just stop your speed. I just want to remove that speed, right? So by the way, if I click on a character, I can see what is seeing in terms of obstacles. So right now where he is, we can see the crossing. This is where he is supposed to go. So we can see obstacles as kind of a radar. So we can check what's the perception of that entity. And we can also see what is seeing in terms of other entities. So he's seeing the cars. We can see the shape of the cars. He's seeing the other blue guys in the scene. And we've got that huge shape here, which is actually that block. So that block, if we keyframe it, it will disappear from the navigation, from the perception. It will allow the characters to go through, or it will just block them based on where it is. So what we can probably do is maybe scale it down so it's super tiny, so people can really just avoid it. And when the traffic light turns orange, we can just scale it up. So we can animate the shape of that collider, and it will animate also the shape of collisions into the navigation as soon as it's connected as an external entity locator, like we've been doing so far. So maybe to improve the system here, what I would like to do is just say to my entities that as soon as they perceive that object, that object is close to them and it exists, and really it's here, I don't want them to navigate anymore. I just want them to stop navigating and just wait for that object to disappear. Because right now we're still saying to them, okay, your navigation speed is 1 or 1.5 and your target is still on the other side. So they're just getting more and more crazy because they can't go through and they can't find a way to go through. So we need to calm them down by turning off their speed. So let's check what we have to turn the speed off. So remember, with the speed of my characters, where do I find that parameter to change the speed of as they go? Well, that's tricky questions, maybe. So if I want to change the speed of the character, we only have 3 different behaviors. So we've got one which is providing a target, one which is providing avoidance, one which is providing animation. So last time we were trying to play with speed, especially when we wanted to make the characters running, that was in the navigation behavior. If we take a look at what we have in the navigation behavior, it has some min and max random speed. And well, we can see that actually we could drive the speed with something else than just some minimum and maximum values. So if I change the navigation speed mode, rather than saying, okay, my speed is random, I want my speed to be controlled by something else. So I've got 3 different choices. It could be random. So this is the default mode that we're having, where we just provide a min and max value. It can be controlled by a per particle attribute. So remember, Golaem characters are relying on Maya particles, and well, a couple of years before now, we were using a lot per particle attributes to specify unique behaviors to characters, but PP attributes, they're not really efficient, they're not really reliable. So we had to create our own system of attributes. So now we can use Golaem attributes. Just to answer a question, it says missing terrain. I do have a terrain though. Let's say you do have a terrain, but it says the terrain is missing. That's probably because for some reason you created multiple terrains and you remove one of them, and it's not connected anymore to the simulation, because you can have as many terrains as you want to into your simulation. So what you can just do to fix this error, you can go into the manager node, expand the environment attribute. Here you figure what are the different environments which exist into your scene. So the one for the traffic is called traffic shape 1, and the one for the pedestrian is called terrain shape 1. Probably in your configuration, you've got no terrain locator, and that is going to say that the terrain is missing. So what you can just do is specify your terrain, probably because you deleted your terrain node for some reason. Maybe you computed it multiple times, and we make the connection with the first one we can find. But if you delete it and you already have another terrain in the scene, it's not connected by default, so you need to reconnect it by yourself. So hopefully that fixes the issue. So let's go back to where we were doing. So we were saying, okay, what we would like to do is drive our speed with a Golaem attribute. So here it's providing a default value for that Golaem attribute called navigation speed PP. So yeah, maybe let's remove the PP. But let's say, okay, now the speed of my character will be driven by an attribute called navigation speed. So my next job will be to create this attribute with the same name and to provide it with an actual value. Also, I want to make sure that I check the checkbox dynamic speed and acceleration, just to say to the system that my speed may change over time. As soon as I get close to an obstacle, I would like to put my speed to 0 so that my characters don't get crazy. And as soon as the obstacles disappear, I just want to resume back to my actual speed. So let's say that the speed is going to be dynamic, so it will change for the whole duration of the simulation. So now what we're going to need is a new attribute called navigation speed that we'll have to feed ourselves. So how do we create an attribute? That's fairly easy. You're going to select on which type you'd like to create the attributes. So here we'd like to create an attribute on the pedestrians. You can go into the behavior editor, select pedestrian into your outliner, into the behavior editor outliner. You can right click, and the only menu that you have available is add a new entity type attribute. So once again, what we're doing here is we're saying, okay, that speed is not driven by a random value anymore. We want to clearly control what's going on. So we want to use a Golaem attribute, which is now a nice and reliable and efficient way to specify unique values per characters. That attribute is going to be called navigation speed, is going to be dynamic. Make sure to check that box. So we're telling to the system that we're changing navigation speed dynamically. And we'll have to create this attribute and control it ourselves. So navigation speed, let's right-click onto my pedestrians. Let's go, into my behavior editor, left-click onto my pedestrian, right-click to open the contextual menu, and add a new entity type attribute. As soon as you do this, you'll see that into your attribute editor in Maya, you've got a new tab appearing. If you expand it here from the behavior editor, you can see your entity type as well, your entity type attribute as well. And we can select it and feed some values there. So we're going to specify obviously the attribute name. So really important to have the exact same name than the one we've been specifying into the other tools. Here it's going to be navigation speed. Probably I want to rename this as well as navigation speed attributes. It's going to be a Golaem attribute, which is expected. Then we can specify what's the type of value. We've got 3 different choices. It can be a floating value, so 1 point whatever, 2 point whatever, or integer value 1, 2, 3, 4, so plain numbers, or vectors, which are 3 different floats. So here we just provide a speed, so 0 not moving, 1.5 walking. So it's going to be a floating value, and well, we can actually range that value between a random mean and max. So well, if we want, we can just set up I don't know, minimum value is going to be 1. Maximum value is going to be 1.5. So that's going to be the default value being assigned to that attribute as soon as it is created. And now that we've been doing this, well, we're good. It means that next time we throw the sim, every single of my pedestrian characters, they will end up with a navigation speed attribute, which will have a value between 1 and 1.5. We can actually monitor the value anytime with the attribute spreadsheet. So from the shelf, right after the target, right after the rigid body, we've got kind of a spreadsheet icon. If we expand it, we'll get a view of all the characters. So the first characters we have in our scenes are car characters. So this is why we're not seeing them. So we can just also filter from the drop down here if we want to keep only the car, only the pedestrians, or all of them. And if we keep all of them, we'll have to go past the car to see the actual value for the pedestrian of my navigation speed attributes. So if I just say I want to display of pedestrian type, now I can see all my pedestrian navigation speed value, which is between 1 and 1.5. And this value here is used by the navigation behavior to provide what's the actual speed of my characters. But now that speed is not dynamic, it's static for the whole duration of the simulation. So that will be your job, to change it and make sure that it turns to 0 as soon as that will disappear. Great. Hope that makes sense. So let's keep moving. I know this session is quite dense. It's quite dense for me too. So hopefully you're at least able to understand, the overall philosophy of what we're doing here. So next is trying to feed that navigation speed with something which makes sense, which is if we can feel if that object, that obstacle is next to us is here, we can feel it, it's really close to us, and it's in our way, then we want our navigation speed to be 0. Else, just navigate as usual, no problem, no avoidance. So that if I can feel that object is something new that we want to introduce into this session, which we called perception. We kind of spoke about it, when I selected a character at some point. I told you, when we are looking into the navigation behavior, we can see what's the character seeing. So it's actually what he is feeling, because it doesn't have any relationship between vision or whatsoever. It's really what's next to him. So we can see he's seeing, that obstacle here, he's seeing the other blue guys, he's seeing the cars. So this is what we call perception. This is used everywhere into the system when we provide avoidance. And actually, we can also take advantage of this perception system in our behaviors and build the behaviors around it. So let's say you're not happy with the way we avoid characters, which is something which happens here and there. Like within Game of Thrones, for example, when they were doing the Dothrakis charging armies, That was Machiavision doing this. You know, they wanted to make their own navigation because they wanted to drive the way the characters were steered and in a really detailed and advanced manner. So they just make their own navigation system based on perception, saying, okay, if I can feel a character on my left, I turn right. If I can feel a character on my right, I turn left. If someone is in front of me, I want to slightly you know, slow down or move it or whatever. So you just define all your system the way you want it to behave, and that produce, you know, a new behavior which was not part of the library before. And by the way, that scene, that exact same scene, is something which is packaged into the character pack. If you check Charging Armies, I think we're lucky enough for Machiavision to give us that scene, and we include it into the character pack. It's using our own asset, but that's the same behaviors then within that Game of Thrones scene. Okay, thanks for the yeah, thanks for letting me know that it's not too deep. Great, so let's move with perception. So how does that work? You may have noticed that when I click on a character, I could see there's a kind of a radar. So there's a shape, and what we're allowed to do with perception is we can design what's the shape we want to use to fill other characters. Sometimes we just want to fill characters which are in front of us. And maybe we want to fill characters which are in front of us, but super, super far. Or sometimes we only want to fill characters which are on the left, but really close. So you have to be able to, you know, define all those kind of different shapes yourself. And we decided to just rely on Maya geometry once again. We rely on Maya geometry for obstacles, so we decided to rely on Maya geometry for perception as well. So what I want to do here is I want to be able to feel the zone wherever it is compared to me, or maybe just in front of me, but I'll filter that afterwards. We'll see. So probably one good thing, one good shape I could use to feel what's around me is just, you know, a classic cylinder. So let's make a cylinder in Maya. So let's go into poly modeling and get the cylinder. And okay, good enough for me. It's right next to my character, so that's great. I want to maybe change its shader so it's great. And really don't move that cylinder far from the scene origin, because what we'll do is we'll consider that the character root is going to be aligned at 0, 0, 0. And we're going to look for the relative position of that cylinder compared to the character. So if you move it to the left, it means that the characters, they will fill a cylinder zone which is on their left, right? Here my cylinder is quite small, so if you want to, you know, have something bigger, you can just scale that cylinder until it has, why it's not actually scaling all the, that's here. So I can scale my cylinder so it defines the actual area I would like to fill. So make it, you know, the way you want it, your characters to be able to perceive that zone. So here I've got just a regular cylinder with the regular parameters that I scaled with a 2.5 ratio on each axis. And that's going to be the zone which will be attached to my root bone of my characters. And every time they're going to move, they're going to perceive everything which is within that zone. And we'll try to filter what we feel, define what kind of stuff we want to feel, because we don't want to take into account the fact that there are green characters next to me or cars next to me. I just want to take into account my external entity locators. So if I want to say that's going to be my radar for my perception, I need to make what we call a sensor around it. So, you know, the same way we've been selecting geometry to make a physics collider, we've been also selecting geometry to make a navigation collider, like the external entity here. We're going to select the geometry to make a sensor, which will be attached to the characters. So let's select the geo. Let's go into Golaem shelf. And one of the few tool we haven't been playing with is the one next to the entity type on the right. We can see we've got a T-post character with kind of a sonar icon next to it. If I hover the mouse upon it, I've got something which says sensor locator. Turn a Maya geometry as a Golaem sensor for perception. Great. So select the geo, select the sensor, it creates automatically into the GLM environment group a new node called sensor 1. So let's rename it pedestrian side or crosswalk or obstacle external entity sensor. Yeah, okay. Pedestrian external entity sensor. So now we know that, and let's take a look at this attribute. It's connected to the actual cylinder. So also a sensor could be made of multiple meshes. You can combine meshes together, and that can define the shape of what you want your characters to feel. It will be approximated with voxels, and for now it's filling the Golaem entities. Great. Just ALA to answer your questions, the error you're getting in channel output could not parse attribute expression, should match something like this attribute. Yeah, okay. I think that's the same error that I had before that I just removed. So that's because on the car characters, we made a couple of channel graphs here. And what we had was animating a left turn light blink stuff. So let me check if that's the same error. Yeah, that's the same error than you. And actually, we didn't define where we should write that value down. We didn't provide the name of an attribute or whatsoever. So this graph, it's not really valid. We will have to put an attribute name here. So what I just did is just disabled that channel. So either you can remove it. So it's don't remove the steer front wheels, the roll wheels, just remove everything else because they are not valid. We didn't road them anywhere because we didn't push that to shading whatsoever. So let's just disable it or delete it or whatsoever what you want to, and that will just remove the error because it's just saying that we don't know where to write down that value. And the next time after the same, now, yeah, it doesn't show it. Great. Okay, so let's go back to where we were before. So we had now that new sensor, which is made by that cylinder, which is filling the characters, which is filling entities. And also, yeah, we'll see after if it needs to be resized slightly. So last thing we need to do to enable that sensor on the character is we need to attach that sensor to pedestrians. By default, they don't know that they are related to each other. So that's something which needs to be done. And, as filling other entities is something which can be quite angry for performances. That's something you may want to enable, disable during the whole duration of the simulation. So anytime you need to enable or disable something for the duration of the simulation, it usually means that you have to use a new behavior that you need to trigger in or trigger out if you don't need to use it anymore. And here, what we're going to do is go into the pedestrian. So open the pedestrian graph, and we're going to try to associate that sensor to our characters. So if we take a look at all the icons, there's one which should be familiar, which is my walking character, which has a sonar next to it. So here we had a sensor with the T-pose character and the sonar. Here it's walking. So now that's simulation based. And if I hover the mouse upon it, it tells activate sensors, assign and enable a sensor locator. So yeah, once again, it can be costly to field other characters. So you really want to do it only when you need it. So let's drag and drop that behavior. Let's assign it with the rest. So we want to go somewhere, avoid the other characters, play a nice animation, but we also want to feel the obstacles in the scene so we can do something with what we're feeling. So that's something which need to be done at the same time. So I've got the activate sensor behavior, and it's a pretty simple behavior. It just takes as parameters sensors, so you need to connect those two together. So right before doing the break, let's connect those together. Let's select our sensor in the scene, which is in GLM environments. Let's press Shift. Let's select my activate sensor behavior. If I press Shift, it keeps the selection. So my sensor is going to be selected at the same time than the activate sensor. Let's press on the map button. So now the two of them are connected. And now if I run the sim, if I select a character, I can see that I have a locomotion behavior, navigation behavior, go-to behavior, which is expected. And I also have an activate sensor behavior. And if I expand that one, I can see that now my characters is filling around them the other guys which are in the scene. If I select that guy here, you're seeing the external entity. And if I want to show that, cylinder in the scene to make sure that it's correctly aligned compared to my character, that's something which can be done with the visual feedback. You just need to expand something called the Maya viewport settings. So you can expand it. Now you've got multiple options to enable. So there are additional data that you can show into your characters. And at the end of all those additional data, so by default here it's closed, the Maya viewport settings, you can expand it and you can show maybe the sensor geometry and the perceive objects. So you can enable those. And as soon as you turn those on, you can see now your cylinder, the exact same size than the one you've been defining, aligned on your character route. And the B boxes, the green B boxes here is what's perceived by the character. So the character is perceiving all the guys which are going to enter his cylinder. And as soon as he moves, he perceives more and more characters, more and more objects. Great. So we're nearly done. Now we've got perception working, and we're going to use the result of what the character is seeing to say, okay, if you feel something which is white, the external entity, then, and you're close to that, and it's really taking a big space into that area here, just stop moving and just wait for your turn to happen. So it's 2 minutes past 9. So let's make a break here. You can take the 5 minutes for a break to actually push your questions if you have any questions regarding what we've been doing so far. And else, yeah, let's meet back at 7 past 9. Okay. Final line. Last hour. Okay, I'll just let a couple of seconds for everybody to come back. Any questions in the meantime? No, great. So let's come back to where we were. So we were having that cylinder, which is now aligned to my characters. And we can see probably that cylinder is way too big. We don't want it to, feel what's under the ground. So I probably will have to scale that or change the height of that cylinder so the characters don't feel what's under, because I wanted to probably put that obstacle under the ground. But yeah, every single character now gets a sign, with its own cylinder, and each of them feel what they have around them. So that's great. Now we'll just need to react to what's here. So feed the navigation speed based on what each character is feeling. So let me just first fix that cylinder 8. So let's scale it down so it represents something which is more realistic. Great. And let's put it slightly above the ground. And if I reflow the SEM, everything gets reconnected together automatically. And now the cylinder is well aligned. And I still see that big white box when I'm in it. So that's good. Excellent. So yeah, just change the size of just arrange the size of your cylinder so it really corresponds to something that makes sense for your character. Should I turn off the perceive object in the sensor? Yeah, I'm going to turn off the visual feedback for now. Now I kind of know that those two are lines together, so I'm not going to need those anymore. So I just turn them off. Next step is, here you can see the characters is feeling everybody, is feeling the other blue characters, is feeling that big wall. And to be honest, what we want to take into account is just that big wall. We don't want the navigation speed, at least having them to stop based on what they can feel from the other characters. I just want them to, well, maybe do I? No, I don't want them to take into account the other characters. So if I want to filter what's going on, what I can do is go back into my sensor, which I've been attached to my cylinder. So it's called the Pedestrian External Entity Sensor, and it's located into the GLM environments transform group. And if we take a look at the different attributes that we have, so here we can see it's connected to the cylinder. It has a voxel size and count. It detects Golaem entities. So here we have a drop down, so we can see either we detect Golaem entities or navigation mesh obstacles. Don't do it, but if we turn this to navigation mesh obstacles, now the character will feel, as the name tells, it will feel the obstacles. And if the character get close to an obstacles, this is what we get into the visual feedback. We don't get the wall anymore, but now we get the obstacles. And by the way, you can have as many sensors as you want to. So you can have one sensor for the obstacles, one sensor for the entity, and react independently from one another. Let's go back to where I was. So I was into the sensor. So yeah, let's go back to Golaem entities. So we can fill Golaem entities. And finally, the last panel, which is expanded, it's called filters. So filters allow us to filter the attributes which are perceived from the perception. So just retain certain amount or certain entities or certain stuff based on different rules. So the filters, they're all available into a drop down here. So you can combine filters together with some operators. So the same than the trigger operators. So you can say, okay, I want to check if what I'm filling is an entity of type whatever, and has an attribute value of value whatever, etc., etc. So you can combine multiple filters together. You can define what you'd like to keep. So you can just keep entities of a specific type. Entity having a specific attribute value, so either a PP attribute or a Golaem attribute. And you can also keep, if you want, an external entities. So that's exactly what we want here. We want to keep external entities. So I'm going to select external entities into the dropdown. I press plus next to the filter. And now I can see my filter gets populated with an external entity. So it means that now we're going to fill Golaem entities, and we're going to only retain Golaem entities which are of type external entities. Let's check what we have now. So if I select that guy here, is having obviously, another blue character next to M, but still you can see that is not seeing that character anymore because we are just filtering the fact that you see just the wall. Great. So final step here is now we know exactly what we are feeling. So the ultimate goal for all that preparation is to use that data to provide a speed, right? Because that's what we want at the end. We want the characters which are here, not to move anymore as soon as they are feeling that zone here. So by the way, probably we could have been making something simpler. Maybe we could have put like a polygon zone here and say, okay, when you are in the polygon zone, stop walking. But I wanted to show you something different. And also, rather than having to duplicate geometry everywhere into your scene here, you can just put external entities and the characters will adapt anywhere it is. So even if you extend your system, have a more complex scene with plenty of different external entities everywhere, you don't have to make sure that you provide a zone every time and you provide a trigger every time and so on. Here, the system will be more flexible to every changes that you will do. But yeah, there are plenty of different ways of doing it. But here, I just wanted to do it with perception. And also that's a good opportunity to show how perception is working and what you can do and how you can use it. Great. So how do we drive that navigation speed? Well, that's always the same behavior, which can be used to set up attributes. That's the channel operator behavior, which we have been using for the cars. So let's add a new behavior to my pedestrian. So I've got one to make my avoidance, one to go to somewhere which loops, one to play my animation, one to fill my characters. And all those together, I'm going to use the data that I have with all those behaviors to feed an actual speed, and that speed will be driving my navigation. So let's grab a Golaem attribute, and that channel operator behavior, that's going to be the last behavior we're going to play with today and for this Academy session. So let's drag and drop it, and we're going to make a pretty simple graph, hopefully here, so no big deal. So yeah, that's my channel operator, and we're going to rename it set nav speed. And by the way, we can rename the activate sensor like fill external entity. Well, and the rest is pretty self-speaking. So set nav speed, we're going to create a new output channel, and that output channel will be writing some navigation speed value in it. So let's close the behavior editor. We're not going to need it. Let's open the node editor. So you can see that when you open the channel operator, you get all the graphs which are in the scene. So they can, or be connected to each other. If you want, you can take an entry for one graph or the result of one graph to feed another graph. So everything is within the same canvas. So it's really up to you to decide what you want to do with it. So here, I'm going to name that output here set navigation speed attribute. Great. So here, what we want to write into that node is going to be a Golaem attribute. So we're good. The Golaem attribute name that we want to write, let's expand it so we can grab it from the helper. So here it has a specific syntax. If you're using 813, the syntax is correct. If you're using 812 or before, it should just show you navigation speed. But actually what we need to say is we need to write this means that I want to write the attribute on myself, because we also got a mechanism to write attributes on other characters, like the closest character. I want to write some data onto that character. So this means I'm going to write it on my data. Each character will write it on its own data. You want to say it's an attribute, and that attribute is called navigation speed. But once again, if you're using 813, just expand, select this, press apply, and you're going to be good. And what I can do to test if all my setup is working is I can just grab an input, put 0 maybe in it. So 0 is going to be my speed. And let's connect this to your navigation speed attributes, and let's see what I get. So if everything is working perfectly, I'm saying that the speed of my character is 0, so they don't get crazy. So that's great. That's expected. If I ask them to go at 3 meters per second rather than 0, now I'm probably asking them to run. So they are running. Excellent. And if I provide, 1.3 or whatsoever, I'm going to drive their speed for them to work. Great. So in that graph, what we need to design is a way to have that speed varying depending on, do I see the wall or don't I see the wall? Up. So I can just rename that node maybe default speed, which is what's going to be used if I don't see the wall. So 1.3 is going to be my default speed. Oops, damn. That's the name of the node I want to write into this. So 1.3 is still the value here. So that's going to be default pedestrian speed. Okay. And now I want to know if I feel the wall, which is next to me. So I'm not sure if you noticed, but there are multiple nodes into that setup here. And the way they're organized is the blue nodes, they are helper nodes. So you've got a group to just group your setup. So it doesn't look complex when you look at it. It's just a group that you can expand. There's a node, so you can put some nodes behind your graph. So that's for the blue nodes. Then you got the green nodes, which are inputs. There's one input which allows you to grab anything from the sim. And there's one specific input which has the radar icon next to it. So that's an input which is reading what comes from the perception. You got red nodes, which are output, that's just one. And everything which is in between are, operation node, what you can use to apply some operation to your actual data. So like multiplication, some logical values or whatsoever. So it means that if we want to read anything from the perception, we can use the sensor input. So let's grab a sensor input node. Now we can see we ended up with a radar shape. And that radar, we can, that's the cylinder that we're having on a character. And when we have that cylinder, we can even define where in that cylinder we want to keep information from. So here, we're just going to keep information in front of us and slightly on the left and slightly on the right. And by the way, let's see what do we get if we put, if we connect it like right away into the system, just so we can see what kind of value it displays. So it displays how much the space is going to be filled, filled by obstacles. So let's take a look. If I select my character and I expand my node. So right now I don't have any obstacles into not visible to my character. So let's maybe select that guy here. So this is what comes from the sensor input. Hopefully, I hope he's going. Obviously they're not moving. So as it's a 0, it means that they are not moving. So as they are not moving, they're not going to be going towards the wall. So as they're not going towards the wall, it's not going to change. So that was not the right things to do. So let's do let's connect what we had before. Or maybe let's grab a plus operation so we can see exactly what kind of result it provides. So let's bring an operator. Well, you don't have to do this because we're going to remove it afterwards, but let's just see what kind of information, what kind of number it returns. So, okay, here I'm just saying, okay, my default speed is 1.3. Let's add this to what I can fill from my characters, and let's push this into my navigation speed. Okay, let's rewind the sim, play it again. Okay, so now we can see that the character feels as is a cylinder around him. Let's bring the cylinders back. From the cylinders is filling the wall, and the wall, we can see it here, is taking a part of that zone here. So the number which is provided here, like 45, it means that 45% of that zone is filled with the wall. So the closer you move to the wall, the higher that value will be until it reach 1. 1 means that, you know, all the area that you have is going to filled by that wall. So what we want to do is to say, okay, as soon as that perception, that ratio has a certain value superior to whatever we want, certain threshold, we want to stop and not move anymore. And as soon as that wall disappear, so we've got, you know, complete window, open window here, just resume what we were doing. If you're, for some reason, your sensor is not filling anything, that's because also the sensor runs not every frame, it runs by default, it runs every 6 frames. So that's an attribute which is within your sensor. So here it's saying detection period 6 means that we're going to run the sensor every 6 frames. So for the first 6 frame, you won't have anything, and every 6 frame you have a computation. So on the first frame, yeah, that's expected that you don't see anything. If you really want to have a, you know, a higher frequency, you can just push this down to 1, for example. Okay, so now we know that we've got a ratio, and probably what we want to say is, I don't know, this is probably close enough. As soon as my characters are this close from my wall, whatever they are coming from. So how much is this value? It's 0.5. Okay. As soon as my occupation ratio is superior to 0.5, I want to stop navigating. And if it's inferior to 0.5, then I want to play a speed of 1.3. Great. So that's going to be final line here. So we want to bring this together. So let's remove the addition operator. So we're going to say if this value is superior to 0.5. So if we want to have a if statement, we've got an operator which is called crowd channel operator Boolean operation. If you don't have it because it has been added into 813, you can also use the operation, just the regular operation. They both have the same operators. We just kept them into the 2 nodes just for legacy reasons. But obviously at some point we'll drop it from the operation node. But if you check here, we've got at the end, we've got a superior sign within the channel operation node. And within the Boolean operation node, we also have a superior sign. So they both have the same setup, but we just wanted to break the operation between 2 different nodes because it makes more sense to have Boolean operation only in one node and mathematical operation in the other. So let's remove that one here. So I'm going to use the superior sign here. So if this value is superior to 0.5, so I need to bring just my threshold. So let's create a new input, put a value of 0.5. Let's rename it perception threshold. Okay. Here it will return 0, 1. So if this is superior, it will return 1. If it's inferior to that threshold, it will return 0. So what we can do is just probably use a multiplier. So multiply 0 or 1 by the default speed. So it will either cancel or just resume my speed. So I'm going to use a multiplier. Nearly done. Those are the last connections. So let's say, let's rename this as sup to threshold. And let's multiply this, connect this to the speed. That's going to be my final operation, which is compute speed. Let's see. Nobody's moving, obviously. Nobody's moving. It's because what did I miss? So 0, 0, 0. Yeah, I need to invert the sign. Here, obviously, so I don't feel anything. So you return 0. Is 0 superior to 0.5? Well, no. So it returns 0. 0 multiplied by 1.3. Well, that's 0, so that's why nobody's moving. So I need to invert my sign here. It's not superior, it's actually inferior. That's newbie error here. So is my perception inferior to 0.5? Yes. Then play the walk animation. Great. So let's see when my characters get close to my wall, they just stop and stay calm. They don't mess up with each other anymore. Awesome. Great. So they all stop. And obviously, final step here will be to keyframe that object or remove that object as soon as we don't need it anymore. So well, I'm not going to do it here, but we can connect it to the traffic light. So it's driven by the traffic light, but I'll just trigger it manually just to show you that it's working. So let's say, so I guess when the simulation starts, the traffic light is green. When it turns to orange, here it is. Let's select this here. Let's add a keyframe here. And let's scale it down until it's not an obstacle anymore. There. And let's see what we get. So, okay, we got all the characters converging. They can see the wall. They stop as soon as the wall, they're close enough to the wall. At some point, the wall will scale down because the traffic light is not here anymore. And here we go. All the characters now go through the passage, and here obviously it's not animated on this side. And yeah, I've got also some cars which are turning. But well, you get the idea, right? I'm not gonna. Well, if you want, that would be a great, a great work to do it by yourself now. Yeah, and they're all separated by a wall now. Great. So yeah, I hope that makes sense. I'm kind of done with the simulation. So let's take maybe, well, if you got any questions with this, so I'm not gonna, complete the shot completely, but now you get, all the key points that you need to align together to get a nicely interacting simulation. I just want to grab the last 20 minutes that we have to speak about a tool which I haven't had the chance to speak about and which is really powerful, which is called the layout tool. That's just to keep in mind that, simulation is just one part of the job. Oh, yeah, and thanks for the poll. So simulation is just one part of the job, but you can see here, it takes a lot of time and knowledge to master the simulation engine and the simulation behaviors. And this is really what makes a CrowdTD excellent, is that knowing exactly what does the behaviors do and how you can design your own behaviors when you need it. So that's really part of the job. But really, simulation is just a way to provide rules to characters. But obviously, you lack artistic control. As soon as you do simulation, you just provide rules, and you never really know what's going to happen. And sometimes your characters are not behaving properly. And if you need to go back into the simulation, it may take a long time to figure this out. Also, if you change anything into the behaviors, that will impact the other characters around, and maybe sometimes you just want to impact one character. Sometimes you want to remove characters which are behaving pretty badly into the scene. and you just want to get rid of all of them. Or sometimes you want to promote a character as a hero and give that to the animation team. So the animation team can take over, fix that specific character, and now you get the shot being approved. So when it comes to all of those operations, the layout tool can become pretty handy into the game here. So let me check the poll. Most of you guys were able to get pedestrian on sidewalks, so that's great. And okay, less of you guys were able to get pedestrians stopping after the traffic light. I expected this to be honest, yeah, I didn't expect everybody to be able to follow that part at the same time. But that, once again, that was just so it's recorded. If you want to review this, you can still go back to that session and try it on your own at your own pace. So what if we want to use the layout tool? So that layout tool is a post simulation tool. So it means that once the simulation has been done, you can export your simulation results. So exporting the simulation results will be using the simulation exporter. So let me just change my timeline here, save my scene, and I'm going to export my simulation. So whatever the state of your simulation, you can actually do this on your side as well. No need to have, a pedestrian stopping at the traffic light and so on. Whatever the state of your simulation, just open the simulation exporter. Once again, you get it from here. And I can just press export, and it's going to write a cache from the frame 1 to 500, which is the time range I'm having right now. And if you remember that well, once the simulation will be exported, we'll switch into a different state for Golaem, which is called cache replay. So rather than waiting for the simulation to execute, now we'll be able to move in time freely. And yeah, the timeline will becomes green. Now I can move in time. I can see what's going on for my simulation. I can see how the character behaves. And if at any time I want to change my my simulation settings, I can just switch the state, go back from cache replay to simulation, and I can change my simulation results, or go back for cache replay and see what's going on in cache replay. So two different states, simulation or cache replay. One allows to see the results of the other. Great, excellent. So let me just clean my scene slightly. There's some stuff that I don't need anymore. Let's hide my population tool. I don't want those anymore into the scene. And if you, by the way, if you go back to simulation, don't forget to bring them in, else your simulation will not be functional anymore because you're hiding everything which is related to the simulation engine. But here I don't need them because I know I won't go back into sim. Okay. And probably something I can do as well is say to my city block here that I don't want to select it neither. So I know some people can put it into some layers. In Maya, I know that there's a layer system, so you make sure not to select them. But I'm not really able to do this. So the only way I know this on my side is go into display. Here I grouped everything. So I went to display, drawing override, enable overrides, and put this into reference. So now if I click on my geo, it's not here anymore. Great. So it doesn't steal my selection. Great. So okay, we are in cache replay. We have been cleaning the scene, so hiding all the nodes that I don't need. Probably I can remove the blocks as well. Those guys there, they are not required here. Great. And let's say I would like to have a guy here. Maybe I'm missing according to the camera angle, the director comes and say, oh, okay, you know what? I would like to have one guy here, one guy there. I would like that guy to wear a sweatshirt. Please remove that guy, animate that guy differently. I want him to turn his head. This is the kind of reviews you get to upgrade your shot to a better version of it. So what you can do is manipulate your characters as if they were, any Maya objects. So if you press F9 on your keyboard, You know, that's vertex mode in Maya. So it allows to select vertices on your geometry. But if you select F9 and you select your cache proxy, your Golem cache, you're now able to select characters independently or as a bunch of characters. And you're able to manipulate those characters as if there are any Maya objects. So here I can bring the translate tool, which I can get from here. Or if I press W on my keyboard, it brings the translate gizmo. And if I move, if I translate those characters, now they are translated. Here the terrain is flat, but if my terrain was, bumpy, they will still adapt to the terrain, even if the simulation has been baked. Great. So I can offset those characters slightly if I want to. I can even change their orientation. So they end up into a different position than before. And they're pretty close to each other. So if I go into rotate and I decide, in scale mode, and I decided to go into a word axis. So that's my scale tool settings. You open it from the tool panel here. If I scale two characters, it's going to scale the actual distance between those characters. So they're going to be now at a different position compared to each other. And you can do this on as many characters as you want to. You can fine tune their position, orientation, and scale. And everything that you would be doing will be recorded into something called the layout tool. So we haven't opened every single tool, but well, almost, to be honest. Yeah, we've been seeing quite a bunch actually. But one we have not been seeing is the one which is next to the blue magnifier icon on the left. So if I hover with my mouse, and once again, I'm pretty sure I lost the tooltips. It's pretty annoying that Maya decided to disable this for no reasons. So if I put my mouse upon it, it tells simulation cache layout tool, view and edit a simulation cache layout. So let's open this. And once again, a new nodal editor. There's so many nodal editor, I know. But we kind of like the way it can be used to design stuff. And okay, let's take a look at what we have. We've got 3 different colors of nodes. We've got first that light blue node. That light blue node tells you which part of the graph is being evaluated at the moment. So here we are evaluating the expand node. And that expand node is connected to the rotate. So we're also evaluating the rotate. We're also evaluating the translation and the selector. So what it means is, that here at any time you can select and change who is getting evaluated. So let's say you don't want to scale that distance between the characters anymore. So that scaling is stored into the expand. You can go back into the rotate, right click and set as root, like we will do with triggers, or press V key. And now we're evaluating the rotation and we're not evaluating the expansion anymore. And we can see in the viewport that now the characters, they are not expanded anymore. If you change your mind, you want to go back into expanded, now you can do it. So it means that all the layout operations that you'll be applying on top of your crowds, they are non-destructive. It means that you've got your cache, and on top of the cache, you are like within Photoshop, like you got your picture, and on top of your picture, you're just adding modification. And at any time, you can go back onto your picture and see how it looks, or remove some layers and see what's the difference. So that's exactly the same here. I can go back to translation, or I can go back to my original state, which was this one here. Let's say for some reason you want to apply the same deformation on that guy. You can just, select that guy here in the viewport. So press F9, select that guy, bring a new selector node. So that's selector allows you to select characters. So the selector is that second node into the library. Drag and drop it into the editor. So now you're selecting that character. And if you connect that selector node to the same stack of deformation, now you can see the same character gets applied with a translation, rotation, and expand. So its distance compared to the other is bigger. So within the nodal editor, you can just drive and reshape your crowd. So I was referring to the fact that I wanted to have one character here, one character there. So something I can probably do is grab one character in the viewport. So let's say him. I can bring a new selector node. And if I put it after the rest, it keeps the previous operation, but changes my current selection. So now I'm saying I want to select that guy here, and I can add a duplicate node. So duplicate node just means that I'll duplicate that character, and as he is duplicated now, I can put him here behind everybody. So now I've duplicated that character and put it in the back, and is playing its own animation. If I want to add another character, let's say there, I can select maybe that guy here, bring a new selection, and once again duplicate it. And now that character is duplicated, and we can put it here. So I can, finally artistic control, and also I can really have someone like the art director on the director next to me saying, okay, I want to fix this, fix this, fix this, and you can iterate really fastly on your shots. If you had to do this, in simulation, it will take you a long time to go into the population tool, add a population for that character, assign the right type, run the behaviors, export the simulation, go back into rendering. So, it takes a long time to iterate through the shot, where here you can just do it like pretty quickly. Here, the two characters, they are exactly the same, both in terms of postures and in terms of appearance. So what I can do is probably ask to make a variation. So I can say, okay, reshuffle the asset of that character. So now he's wearing a different setup for the geometry. Before he was wearing the sweatshirt, now he's wearing the t-shirt. I can also ask to shift him in time. So he's playing the same posture at the same time. So they are exactly the same. So I can say, okay, let's time offset that guy by, I don't know, 15 frames. So now he's not exactly the same. He is shifted by 15 frames. And obviously, I can remove also characters. Let's say those guys here, I don't want them anymore. I can bring a new selection and kill them. And now they're not here into the simulation render anymore. So there are plenty of layers you can play with to, influence shaders, to duplicate characters, snap characters. And finally, probably the last thing I can do is maybe reanimate a character. So let's say you're not happy with that character here. Once again, I can select him. I can bring a rig node. So let's apply a rig node. Right click to create a rig node here. And that's going to create automatically an IKEA rig. So obviously it's not your studio rig, but that's a rig that we can create from the data that we have from the character. And that rig can be reanimated. So you can ask an animator to, jump in and reanimate that character. So you can do anything you like. So change the pole vector for that character, put keyframes, and everything you'll animate and keyframe will be saved into our own Golaem layout layer. So within the graph editor, as soon as you're going to move those controllers and put keyframes, they're going to be stored into a specific layer. And when you're going to save those, it's just going to be saved into a layer system. So here I've been applying a deformation on the arm, for example. And, as always, I can select other characters in the scene, like that guy here, and apply the same modification on that guy. So I can ask him to copy the same rig operation that I've been doing. And now I can copy, fix of animations around to my different characters. And when I'm happy with that, I just have to save it. So let's gonna save it, call it layout. And oops. If I create a light for Arnold, check if all my rendering settings are correct. If I press save, get a nice view, remove my cylinder probably. And now it should get rendered with all the modification I've been applying, both in the simulation and both at the layout. And yeah, I get all my characters with their diversity, with what I've been asking them to do. With the duplicated characters, with the animations I've been reassigned, and you can see render time is pretty decent here, despite the fact that I'm having 600 characters in the scene, I think, something like this. Yeah, so that's the layout. So I went super fast through it because that tool is it's pretty easy to understand. There's no specific knowledge, so there's no need for us to spend too much time on this. There's a pretty great tutorial which is called Introduction to Layout, which walks you through all the different layers. And just keep in mind that that tool is here to help you fix in post-process what's wrong in sim. So don't try to fix everything in simulation, because it can be really a pain, and iteration in simulation can be really, really long, except if you're an expert in crowd simulation. But really, the layout means that anyone in the studio can jump within that tool, fix your shot, and you can have multiple artists using the same cache and just applying different deformations on it. So I hope that makes sense. And yeah, there's plenty of tutorials if you want to know more about it. So that kind of wrap up today's session. So next session is a bonus session where we're going to speak about the Unreal integration. So we've been working on the Unreal Engine for the past 2-3 years, and now we've got something pretty mature. So the next session is really optional. It's really, if you are using Unreal into your workflow, if you're curious about how Golaem is running into Unreal, you can come, you'll be welcome. Make sure that you install Unreal before, because Unreal takes a really long time to install, either 4.27 or 5.0. Stable release, the one you can get for free from the Unreal website. And then after that, so in the meantime, also, if you don't have a license yet, please provide us your MAC address. So we're going to provide you with a commercial license that you'll be able to use to make your own shot without any watermarks. And for anybody who would like to do it, we're throwing an assignment from today. And I think the date of delivery for the assignment is in, well, I can't remember. I think it's beginning of June. I'll let Alex put this into the chat box. So if you want to make your own shot, whatever it is, it can be, flying characters, pedestrians in the street, battle scenes, do whatever you want to, be crazy and have fun. That's probably the main the main stuff. So have fun with this, and render it and submit it to our website, where we're going to provide you all the details. And at the end of that assignment period, so we'll be able to provide support. So if you come on Discord, we'll be really happy to help you out to have the shot that you really dream about. And when it's rendered, you'll also be able to put it into your reel. And we're going to review all the shots on, so deadline is June 5, midnight. And we're going to review all the shots on Monday, June 6. We're going to invite crowd TDs from, no, it's not the right date. Okay, well, and check on the website, it's written. I'm messing up with dates now. And yeah, we're gonna invite crowd TDs from studios, and they're gonna review the shots with us. So it will be, a great way to learn information and also meet people from the field. By the way, today I was called by 2 HR from 2 different French studios who are looking for crowd TDs, even remote, for jobs this summer. So, if you guys make a shot, an assignment, and it's good quality, we'll be happy to recommend you to those jobs here if you want to start a career in crowds. And there are going to be 2 nice projects and a good project to get started with. And there's plenty of, positions being open at the moment. Teams are recruiting, all around the moment. So this is also why we're organizing the academy. So we've got more people being trained with Golaem, and who can, be engaged in studios. So, okay, review is on June 8th. I think that's a Wednesday. And the deadline is going to be on, June 5. Yeah, if you haven't done so, connect us on LinkedIn, and also get onto our Discord. That's going to be the best way to, get support from the community and from us as well. So I hope you enjoyed the session. I know this one was kind of a monster because we went pretty deep. compared to the previous one, at least. Hopefully it didn't scare you, and that was fun, and hope you enjoyed that academy. I enjoyed it a lot. Once a year is I mean, it's good enough for me, but that was good fun to do it, and you know, to also dig with the software. You guys take care. If you want to, you know, get in touch, we'll be on the Discord, and yeah, can't wait to see the assignment. Hope a fair amount of you guys will try making your shots. So see you on the May 31st if you were going to attend the Unreal. Else it's going to be June 8th.